One online if there is anybody. And it seems to me we are losing people, or we haven't regained all the crowd from yesterday. I guess it was such success that they're still rehabilitating. So maybe we should give a few more minutes so they could come and take a seat. I cannot restore the timer, so it cannot go unwind back a little bit. Well, actually, why am I saying I can't, right? Yeah, well, make it happen. Let's do it. And okay, 5 minutes at it. Last minute, probably the ball drop. One of our minions could descend.
The DataLad logo flying all over the place.
Oh, we saw that yesterday. Yeah, there were animations. Okay. And we should begin. Okay, we gave them a chance. And I bet more people will come, but here we are. Welcome to the day 2 of Distribits. And first of all, I want to thank again all those involved and who made it possible, but especially you, because without you, it wouldn't be a meeting of this scale, I would say, right? We would just chat among ourselves, but we did it in the evening, and I hope you did that too. So you had nice conversations, and I hope that you could share some of them with us, right? So there is a website you could get there by scanning this QR code and upload your photos, which you're willing to share. And I just want to spend some time to kind of, that's an error. That's a funny thing. There was a website. I clicked, maybe if I click directly here, it will work. Let's see. Did it go anywhere? Okay. So yesterday began for some people, maybe in different countries, right? For me, it was actually the day before, but it was all a blur, right? So we came through Amsterdam, we spent some time there, and the stinker was really nice. Some people then joined in some pubs before the meeting. I hope you did too and had fun. And for some, it was also a morning run, either yesterday or today. Some people managed to do it. I wasn't in the condition. And we had wonderful helpers, right? So they're all there. Joey was presenting one of the early talks, and we did get our group photo, although I'm not sure if that's the best resolution we could do. Maybe we could redo it, or not redo it, but re-upload better photo. I don't know. I downloaded just straight from the metrics channel. And here is some other photos which we managed to upload. But again, if you have more photos, please do so. Please upload them to this photo album. And let me maybe redo my speaker view here. There we go. I'll steal this away. And we go here, full scale. Here we go. Okay, so photos, if you have any, please upload. There is live stream going on, so it's still at the same location. Happen you go somewhere and still want to watch, please join on live stream. There was a good coverage already on Mastodon, and we have a hashtag Distribits, which was consistently used. And on Twitter, I wasn't that consistent, so there is no hashtag, but you could find those tweets under DataLad. And I advise or welcome everybody who wants to help us to cover the event and promote it. Please share those tweets or mastodons with the hashtag as well, post new ones. And as for logistics, so there is still tomorrow for some of us, and it will be hackathon for those few. Coordination is via metrics, and we have GitHub repository for you to propose your project. And what we want to specifically mention is unconference today. So you've heard really nice talks yesterday, and even if you didn't prepare a big full-fledged talk, there is opportunity today. We have like 45 minutes to present whatever you want to talk about. It doesn't have to be about DataLad or git-annex, although it could. Let's say during the opening talk, I gave a chance. Unfortunately, I had to abruptly end all the discussions about how you use version control system. Maybe you could share some of experiences there, right? So maybe there's some uses which you came up with, which worth sharing, right? So unconference gives you that possibility, and to coordinate, just get to the metrics room on Hack Room, which will be also used tomorrow for the hackathon. And at this point, maybe if you want to express any opinions or recommendations to the organizers in this public forum from day one, so we could improve day 2, you're welcome to do so. And do we have microphones ready though? Yes, we do. So anybody wants to say something or recommend or reflect upon yesterday? No? All good? We were discussing yesterday in the evening, was it good or was it bad? And we decided it was great. But then some people still came up with how could we improve? 5 minutes left for me. But I think we don't have to stick actually to that time, and I could even surrender it to the next people. But still, there is a chance to discuss maybe, and anything which you think could have been improved? More water, less water, sweeter coffee, yes?
Yeah, I just really like the panel discussion. I haven't seen that in a conference like this, that all the questions are saved for a panel discussion, and I think that gave it a bit more group spirit, which I really enjoyed. Thank you for that.
Thank you. Thank you for the comment. And indeed, it's I think it's better format, right? That it gives chance to speakers. Those talks, although we didn't give any sectioning, right? It's small conference, so it would be kind of silly preemptively sectioned talks. There were a good number of talks which are under similar umbrella, right? So let's say coming up session will be scientific use of technologies, right? And we'll go through those. Anything else? Anybody? Philip? In the back.
Hi, thanks. Yeah, I think the conference is going great. I think yesterday I was telling people it's a good signal-to-noise ratio, lots of signal, not much noise. And I just want to say I like the use of the Matrix chat rooms. You showed some pictures of me and Edward, watching the game and having some beers, and we wouldn't have found each other without the Matrix chat room. So thanks a lot.
Thank you. See, Remy, we could have ran together if you read that chat room yesterday. Damn it.
I'm not going to say that we could have run together this morning if you hadn't done too bad.
That's true too. Okay. Anything else? Okay, so hopefully this will be also opportunity if you start any conference, right, or small meeting, those ideas could come handy. And by the way, all these slides, even they're online in a repository, which we could share this one, I think. This is intro talk. I think it might be already public. Okay, so without further ado, maybe we could get to the talks. No objections? Good. So first I would like to welcome Julian Cassesa. Good, okay, thank you, Julian. So his talk will be neuroscientific data management using DataLad. And Julian is a postdoctoral researcher who works on the cross-section or intersection of cognitive, computational, and systems neuroscience to understand the robust flexibility in the human brain and perception, cognition, and action. In his research, he fuses a variety of techniques from the human neuroimaging toolbox to make progress on those questions. So give Julian a heart welcome, round of applause. Thank you.
Thank you, Jarek, and thank you for having me at this very special conference. It's not a common one for me, because indeed I am the kind of person that wouldn't know what iNodes are. I looked it up yesterday, so now I know. But I'm really a cognitive neuroscientist by training. Most of the things I'm going to present I did in Berlin at the Max Planck Institute, and I'm now based in the Netherlands at the Donders Institute. And I tend to ask questions about the brain, try to get answers, and I try to get them via diverse neural and behavioral measures. So we design tasks, record behavioral responses, we measure brain activity on a fast time scale by putting electrodes on people's heads, we put them into brain scanners, we track their pupil, and we also run computational models on those. So these are quite complex studies that ultimately have the goal to, at some point, get some results and write up a neat narrative that either confirms or disconfirms some hypothesis that we had. But on this path, there's actually lots of stuff that's happening. So we do collect the data, and we set certain parameters to collect the data in the first place, which is already a choice. But then we have more choices. So we're using varying tools, and we're faced with a variety of options. We are oftentimes writing our own code. And ultimately, these results that we obtain will be dependent on a lot of these different parameters. One thing that we would like is to make these decisions as fair as possible, including reusable. And I've always faced this challenge of looking up at the hill or standing on top of it and looking back and seeing just how messy some of the directories actually look like. And indeed, it's not quite trivial to solve this problem because you basically don't only track once, but you run it for all of these different data modalities that you have that ultimately you also want to integrate. And so when I stumbled upon DataLad after having some experience with Git and version control and code, was really a kind of emerging blurry vision of using this to really tackle these derived workflows for a lot of these data and organize them in a way that I can better work with them, but that also would make it potentially to share all of these steps in an integrated fashion so that people could interact with it just like I can on my computer. Why do I think neuroscience and science in general is a useful application for this type of tool? Well, we're dealing with varying file sizes, including large binary files. If we're looking at fMRI data, large here doesn't mean petabytes, but at least a few gigabytes. And if you have different analysis path lines, for example, those can quickly skyrocket. You have multimodal data formats. For some, you have some principled way of storing the raw data, but once you're getting to derived data, it's really a Wild West. You have sophisticated workflows, so you're acquiring them, you're pre-processing them, you're processing them, you're visualizing them, and ultimately what you will see in a paper is only really the output stage of what goes in there, and you put a few parameters in the paper of the decisions that you made, but it's not in a way that people can actually kind of see where things came from. You have multiple software packages in the path line, and we're increasingly sharing our content, but with varying reusability, I would say, right? Sometimes we only have the code available and not the data. Sometimes there's data, but it's really unclear which part of the code was used. And so that was always a bit of a gripe for me. So the plan for today is to give you a perspective of me as an enthusiastic user of how DataLad can support some of this reusable research data management facing all of these challenges with my particular application in neuroscience, but also discuss in the end some potential roadblocks that I've seen both in my own work and when I try to teach this to others, with the goal really to start a conversation on people trying to maybe accomplish similar things and seeing how they are kind of approaching these things. And it can really be a rabbit hole. This is not just for Easter. So I know some of you will be super bored in the next few slides, but I want to give everybody a quick intro of what the actual components are that I use of DataLad. So fun fact, I've never used the DataLad run command, and I think that's one of the big selling points, but I've just never used it. Of course, we start creating a data set that's similar to what you would do with a git command as well if you want to have a pure git directory. And that has, well, really served me well because you have these kind of quick shortcuts telling you where data goes. So for example, text goes to git, everything else goes to binary files and so on. And then basically we add data and we run a DataLad save command. We can run a status command in between, and I actually like that in Git to kind of see what's changing. But that's basically the workflow, and it can be as intuitive as this. But for me, it's usually not, because I think the killer feature for me is really subdata sets. And that's, to me, where DataLad excels at. Oftentimes, I am facing the challenge that I have maybe a fairly consistent source of raw data, but I actually do quite a lot of different things with them. It might still be just one pre-processing stage where, for example, I clean up the data and I filter it in different ways. But then these really go into varying kinds of analyses, and these analyses can go into different types of papers. And this kind of structure, both on a local drive, can be challenging, but if you want to share this stuff in a kind of useful way for others, I think that's even more difficult. Here, the nice thing with DataLad is that you can have this modularity. You can register basically subdata sets as links to these super directories in a way that if I share them, and this is, for example, a screen grab from Jin, you would, if this is the preprocessed directory, see with a version tag what the raw data were that you were actually using. And you can update this, and maybe that gives you a bit of an intuition for just how this isn't really necessarily provenance, but at least version tagging of these different components. And it really allows for really complex hierarchies that are also quite efficient because you're already modularizing things. And then the other nice thing that comes with having such a nice data structure is that you can share them relatively well efficiently, because you can basically share just the super node and everything else will be attached to it. But you can also just choose to share specific parts of these things, so it's also flexible. And there are nice DataLad commands that let you do this. In my work, I oftentimes use Gin just because it is a very nice integrator, and for me it has been a really nice test bed to just see whether things are working. And the key here is really the recursiveness of the operations. You basically go to the super directory, you tell it, okay, run everything recursively, and in the back end, it will try to align all of these links. Fingers crossed that the links are correct. And I think there's cool features with this that I'm still trying to get set up. So for example, you can have variable access permissions for these subdirectories. You can host things in different locations, and I'll try to give you a bit of an impression of this in 2 projects. So the first one was a contribution I did to a community effort called EEG Many Pipelines. And that was really a project that aims to assess the influence of pre-processing and analytic variability on whether we make a binary choice to say that hypothesis is confirmed or disconfirmed. And it was not only about getting a yes or no answer in the end, but the people running the project also really wanted to see how people analyze the data. So actually having the analysis pipeline with the idea that people could learn from how other people structured their code, and also looking at whether they could rerun the code themselves. I thought, okay, this is quite cool. This is kind of the project where having access to shared files is quite good, and managing code and pre-processed data as well, because actually they're going to be analyzed by people. So let's just package them in DataLad. And here's just the first example where I think sharing data and reusing data is, of course, a DataLad scenario. The original team published this in zip folders, and I mean, this is a bit of a joke, but it was actually shown at some point, and it's just not fun downloading even 10 gigabytes of data as a zip file, right? I think tools like DataLad are great even at this kind of first step, and then might become even more useful afterwards. So I can quickly run this command just as a demo, and this is a DataLad install command. You can see that it has a -r flag, basically telling the system to recursively fetch everything. I will get some errors here because, or not errors, but I will be queued to provide some credentials, which I don't want to provide right now. So I won't get all of the data, because indeed here we have a scenario where I didn't publicly release the raw data set because people still want to release it in another fashion. But I did release the derived data from it, as well as the results. So the original data set was around 100 gigabytes. And well, as you can see, we're making quite some progress retrieving all of this, basically with the same kind of structure that I had on my local drive. The code is already available because it's fast to download, and I could grab the data if I wanted to. You can see there are symlinks here via DataLad get commands. Okay, so let's take a look at some of the features that we have here. So on the one hand, you really replicate the entire project structure as I had it on my drive in a very fast way. In this case, I went for, you can see this is a GitHub link, hosting a super directory that contains multiple subdirectories that are hosted on Gin, which is also where the binary content is stored. And that makes it both accessible or findable quite easily for people on GitHub, and then has the actual data grabbed from Gin. We can only get what we need. Here in this case, I also nested the bits input data set. I'll show you in a slide. We have a versioning of all of the publicly available toolboxes that were used in the processing, and we also have a branching of different analysis versions. Just to give you an overview of what this looks like, so we basically have here 3 subdata sets, one for just the raw data, one for the pre-processing, and one for the analysis. In this case, the EEG data set is also nested in the pre-processing under data inputs raw data. So you actually have a flat hierarchy that is basically linked to some recursion. So if I make changes to the actual raw data, because I noticed that there's a file missing or there were errors in the coding, I could update this, run, in this case, manually, because it's not run by a DataLad run, the pre-processing, and basically have a better idea of where things actually are. So that's the recursion here. The other cool thing that I just wanted to highlight that was quite a nice use case for me is that traditionally we have code and outputs either in the same or in parallel folders, right? We create a version 1, version 2, version 3, and I think that's been always the example for code that we kind of want to get away from this. But now we can also do this for data, right? We can do a branch, for example, with a different filter at the output stage, and you actually have a version tracking of what the code changes were. In this case, I can then flexibly switch between the branches. And because, for example, for the README, I created a README where it basically loads in the file name of the file in the data folder. You can basically have the same README that just read in the different version files. So if I show you how this looks like on this page, you basically have, in this case, a master branch, and these would be all of the results that I obtain with this version of the analysis. But I can also switch either in here, the web interface, or on your computer, switch to a so-called no-CSD branch where I applied a few different parameters, and basically the outputs have changed. In this case, there's probably a bug in there. If anybody wants to fix it, please do. But I think this really gave me a kind of view of the utility of some of this, right? I could, at, for example, the review stage, tell my reviewers actually, okay, here's an alternative that I ran according to what you wanted me to do, here's the results, while still maintaining the original version next to it with relatively high efficiency. So much for the first one. The second one I want to briefly touch upon is that this also scales to these kind of multimodal experiments. So the experiment that I've just shown you with the EEG data was a relatively circumscribed one. You're getting a data set that is fixed. You had very clear instructions on how to analyze the data. So the project was relatively small. Now, the nice thing is that it does scale well. In this project, we really measured everything we, at the time, could to answer the question that we had. We measured behavior, we ran behavioral models on it, we measured EEG, and all of these, by the way, are sub-data sets that are different analyses. We measured pupil, we measured fMRI, and ultimately also wanted to bring it together. And actually, everything you see on the slide, unless it has the kind of code data doc structure, is a sub-data set in its own right. So every kind of component of pre-processing or analysis, in this case, is a sub-data set. And this is the structure, how it looked like on my computer, and I can actually share that with you in a way, well, that is relatively flexible. I could choose to drop some components if I don't think they were relevant, for example, for the analyses that I actually reported on. But I have that flexibility of actually sharing it in as it was when I did the analyses. In this case, I tried to push the frontier a bit in terms of what I was able to do and still am able to do. So here I have a GitLab, institutional GitLab that hosts the super data set and then tries to again point, so this is basically a complete copy, just missing the binary content or the annexed content, and then the annexed content resides along with all other information also in an internal GitHub Gin repo. And to me, that was quite a nice idea because we are actually not able to share all of these data. There are some anatomical images that are not defaced. And so I actually do think it would be a cool use case to make some parts of this private and yet have a public-facing interface where you, for example, could access all the code, all the tools, and you might just not be able to access all of the data without me giving you permission, for example, after signing an agreement. We can also take a quick look at running this, just again to show that things move relatively fast. So let's actually type things. And again, here we'll probably get some errors. Wait, what happened? This it didn't like? Yes. Okay. And this will still take a bit because it is massively recursive. But that's basically this one. But it will populate it with all of the sub-data sets in here over time. I think this is still quite magical. So. All right. Some principles that have served me well so far in trying all of this. Well, I think you can see I'm a fan of nesting. And I really think it is one of the things that really allows novel workflows that I just really hadn't had in mind so far. That also comes with the need to really think about, though, what are the separate sub-data sets and what is the nesting structure. And for me, it's, for example, separating them by modality, pre-processing, different analysis stages. And if things grow too large, either in terms of file size or file number, also creating different subdata sets, for example, for different participants. But you actually do need to have a plan of how this should look like. Otherwise, it's going to get a bit tough. For me, it helps to also have a common naming to actually visualize for me where the subdata set starts. So I always use, for example, code, data, doc, figures, tools as kind of modular components of the subdata set. And this is part of a bigger problem of, we should think about how to name files. And I think, again, this is quite a wild west at the moment when it comes to science. To me, a realization was also that it makes sense to keep hierarchies flat and exclusively use underscores for folders. This might seem myopic, but if you do have a folder structure like this, it will ultimately get turned into something like this. And I know there's alternatives, but we do need to actually, I think in the way that we name the folders themselves, how they will ultimately appear, for example, in URLs when they need to be accessed. And in the past, or in all of these projects, I worked sometimes a bit forward thinking, but I was also retrofitting existing project structures, which makes it a bit easier because I actually know what the structure looks like. So I want to quickly go into a few roadblocks that I think still exist. One is on the side of infrastructure. I ran into various challenges, even getting Git to run on some institutional servers. So I do think we need some documentation also for sysadmins to know what are the requirements to actually run these tools, because it's really no fun if you just can't use the tool in the first place. I do think that recursive sharing for me is a really big use case, but it does become more complex when you do desire some degree of privacy in subdata sets. So for example, some platforms like Gin, to the best of my knowledge, don't allow automated changes or computational changes to access permissions of subdata sets. In my case, I have 400, so I don't want to go into the GUI and always click, yes, make it public. To me, it's also a problem to basically organize the HTTPS and SSH access if I want to share publicly and with passkeys, for example. There's some funky cross-platform integration if I want to share on GitLab and Gin, for example. And yeah, I think the conversion of folder hierarchies makes a lot of sense. If I already know the structure, it becomes a bit more challenging if I don't. Also, institutional policies in the level of really big architecture can be sometimes unclear. We discussed this a bit yesterday, but there is a benefit of archiving things in an unannexed form because you less rely on the tools to be available in the future. And also some institutions now work with quite tight project size quotas, and so keeping data in check and not making files explode is a big one. The second one is distributed collaboration. And none of these projects I actually used the key selling feature, namely the distributed collaboration aspect. And I do think it is now harder for other people to interact with the same files because symlinks do require dedicated procedures. And there is a conceptual novelty to this, right? I wonder whether people can use DataLad without knowing at least the Git principles. And so sometimes when I'm teaching the stuff, people do get confused about why there's now different names for things that have a fair equivalent in the other language. It is a command line tool, so people will need to use it. People will need to have some debugging, but they also have the community. So I think we can get there, but we should keep in mind that it is still a constraining factor. And I think for me, what's actually as a user very important are face validity or trust checks. Did the things that I wanted to achieve actually work? And GUIs, for example, are great in this, right? If I see there's a symlink and I click it and things get downloaded, I feel quite happy that things actually worked out the way that I set them up. And yeah, it makes sense to have a management plan. What are the subcomponents and how do I want to set them up? And ultimately, I think we need more incentives to showcase novel use cases. I do hope that I gave you some examples of how I use DataLad, and I would be very happy to kind of keep the conversation going about whether anybody has similar goals and how they try to get there. So thanks again for inviting me, and also thanks for Repronym for giving me some incentive to try to teach DataLad. Thanks.
Thank you.
Thank you.
Thank you, Julian. That was wonderful. I felt like I could have given such a good talk, but because you covered all the topics which kind of come to mind in my case, and workflows are underappreciated, I would say, in terms of exposure. So now I want to surrender. You could prepare, connection to Jan Busha, and who is also known as nobody in person, I think.
Yes.
So you could see that handle, and now you could put even face to it. So Jan will present on how to stay in control with all those tools you've mentioned, and he's environmental scientist and meteorologist at the University of Tübingen. He loves free and open source software, and among many other things, he built a sensor system to measure natural CO2 emissions. Please give a round of applause to Jan.
Yeah, thank you very much, Jarek, for the introduction. So this is me. Initially, I named this talk Staying in Control of Your Scientific Data with git-annex, but also from yesterday, I learned again that scientific data is wildly different. So let's just rename this talk to hashtag git-annex all the things. I think this is fitting a bit better. Yeah, so Jarek already introduced me. I'm also a lot into this maker stuff, 3D printing, CNC milling, and this is also what I did and learned during my PhD. And I've been using git-annex in this whole process. I'm fairly new to it, like I think 2 years maybe, but I absolutely love it. So a bit of background. This is the Starzer site. I also call it the Wonderland sometimes. It's a meadow. And all these yellow dots you see here are spots where natural carbon dioxide comes out of the ground. So there is a geological fault there, which basically means an earth crack. And this forms a pathway for carbon dioxide to come to rise up from a magmatic chamber underneath. And this carbon dioxide has been mined industrially even for the last 100 years around. And they made carbonated water from it or dry ice. But at some point, the yield stagnated, so they stopped. And but the holes, these so-called MOFETs, where CO2 comes out, they continue to reappear. And the project I'm working on in my PhD has as a goal to find out how much exactly that is. Does it change over time? And this is you can read more about this site here in this publication here. And so what do these things look like? They're called MOFETs for some reason. Who knows Italian might know that moffetta means skunk, so stinky animal. And they do in fact stink sometimes because also some other gases come out of here. So there are big holes, small holes where you can only see that the gas rises up if it's completely underwater. And but this hole here, for example, emits, just to get a feeling for it, half a ton of CO2 per day. This one hole, and volume-wise, this is like 4 small offices, or driving from here to Lisbon in Portugal with a Porsche Cayenne, or half across the USA. Joey, for you, what it emits, what the car would emit. And no, this is not what's causing climate change. Like the anthropogenic emissions are 2 orders of magnitude larger, but still, this is a baseline we have to consider. Yeah, so to measure what's happening there, you cannot just put one measurement device at one point into this field, because as you saw, it's very scattered and very heterogeneous. So no matter how expensive the device is that you will put there, it will not be representative. So our approach is to build a sensor network, and I did that. Here you can see some of the stuff that I made for this. It's a self-made printed circuit board. We use a microcontroller here. I tried a lot of networking approaches, but in the end, I found that keeping things simple is the best. So we use an ESP8266 microcontroller, super cheap. It can do Wi-Fi. This is all we need. And it communicates to a central station, which is a Raspberry Pi, powered by a ridiculous array of solar panels. And this thing has a SIM card and can talk like this to the outside world. So to send the actual data, I chose, and this is where the data comes in, the super simple protocol MQTT. I don't know if you know it, but it's a very, very simple and microcontroller-friendly publish, subscribe protocol. So it's basically like Mastodon, but for microcontrollers. So you can publish an arbitrary binary message here. This is the message. So in my case, I use a string, a number, and the unit to a certain string topic. This one is not binary. To a string topic, and I chose rather long topics. These are also partly auto-generated because I wanted each data set to be a bit self-describing. And the cool thing is you can just stream the data. I could do it right now, and this is like a tail-f. It spams your terminal. And this is very helpful in the field to debug and also to just store the data. Like I didn't even bother to write a script that puts this into the nicer format. I'm just using this mosquito sub command line that just outputs this, and I'm saving this. But not just this, because without time information, this doesn't help. So we add some time information here with the ts command. And by the way, you know who wrote this? I found this out recently. It was Joey, apparently. So thank you, Joey. Another tool that, that helps me a lot of avoid some headaches. So this is the data that I stored. And if you restart, it compresses very well because there is a lot of redundancy in there. And if you restart this process every couple of hours, you basically have a file chunked read-only database, which is perfect for git-annex. And I was really happy when I finally found git-annex. My solutions before that I hand-rolled with rsync to back it up and stuff, it was just not good. And git-annex is really perfect for this. So now that I have these files that are not a database, yes, I know probably some of you really like databases. I also tried the database approach and failed miserably. It was just simple files that you can grab are just so much easier to handle, I think. But to make searching this data a bit easier, you can store some pre-computed information in git-annex metadata. So for example, I made a script that runs regularly. If new files come in, they find out what kind of sensors are contained in this file, from when to when does it contain data, blah, blah, blah. And you can make a nice table here that shows you how long the time span is, how many copies I have. For example, these files have 7 copies. It's quite safe. I can be sure that even if like the field explodes or university drowns, no way, the other way around. That these files are safe. These two are only in the field, and if the field has a problem, I also have a problem. So this is how the network looks like. Each of these dotted arrows are git-annex doing its thing. So we have the Raspberry Pi in the field that receives the data. I connected a flash drive to here. Git-annex syncs all the data to there. And the slow mobile connection, I can squeeze some files through there if I really need it, but it's absolutely not enough bandwidth to output. Also, the webcam images, it's just not possible to transfer that via 4G. So this is where git-annex's cool feature, the sneakernet, comes in. For those who don't know what that is, it's basically internet, but using your sneakers to transport information. And this is what I do. I go into the field regularly, and I swap the flash drive, put a new one in, and git-annex does its magic, synchronizing all the metadata, all the locations where files are, and I can put it into arbitrarily many hard disks, any servers, and can be really sure now that I finally don't lose data anymore, which happened way too often before I had the system. And by the way, thank you very much, Joey, for making this only in-group matching expression a thing, because this helps. Then I can say everything in the field wants all files that are only in the field, and not that it tries to pull down data from here over the internet connection. That doesn't make any sense. So thank you very much, Joey, for this. On another note, I'm also employed at the University of Bonn, and my project there is something completely different, measuring atmospheric stuff with multicopters. We are doing a summer school this August. By the way, the application deadline is today. So if you know anyone who is interested in learning how to do atmospheric profiling, which is measuring things vertically, atmosphere things. Just let them know. And our part is to do vertical measurements with multicopters. And I plan to just put a Raspberry Pi on there and also use git-annex with like to get the data off, to keep an overview of all of this. And I mean, as it's also a bigger campaign, it's at the Forschungszentrum Jülich, by the way, some of you know it. And if some of you has any ideas or experiences with using git-annex or DataLad in a lively measurement campaign, like where multiple people constantly add stuff, and I'm very happy to hear about it. Because I think it can also get out of hand quite quickly. Otherwise, I also played around with a lot of like things that you can do with git-annex. So this is where the hashtag git-annex all the things comes from. So I wrote a Thunar plugin. Thunar is the file manager for the XFCE desktop environment, and I was already familiar with this plugin system, and tried to make something for this. And we also use in the family, we use git-annex to synchronize our like documents and pictures. And this is very helpful that you can just go into your file manager, right-click, and then you have the git-annex functionality right under your mouse. So you can sync, you can add the file, get, drop, lock, and also this metadata management. So there is this properties dialog where you have rudimentary support for modifying the metadata per file. And I also built in this metadata view thing. I don't know if you know about it, but it's very, very cool. It means that git-annex can make you a new orphaned branch that doesn't interfere with your main branch, and that is organized according to metadata. So for example, if you have a music collection and you have set metadata like artist and album, you can tell git-annex, okay, make me a view where the first folder layer is the artist and the second is the album. And the coolest thing about this is if you move things around and rename folders or in this view, git-annex will update the metadata. So this is a pretty graphical way also of managing metadata. And I think this is really cool. With this plugin, you can also build these views interactively. One other type of data that's also important to me, probably also others, is the time you spend on certain projects. Sometimes you're even obliged to track the time that you spend, like if you have multiple employers, like me. And I tried several different solutions, like maybe you know Time Warrior or the time clock format, so those of you who use Emacs or HLedger. And I was not really satisfied with those, and I thought, I want to have something that works everywhere. So a command line application even works on my phone. I use a Linux phone. Yes, git-annex runs natively on it. And I don't want to bother with this syncing stuff. I don't want to manually reconcile merge conflicts on my phone. Really, I don't want to do this. So I thought, how about we try to use git-annex as a data backend for a time tracker, just as a silly idea if this would work, and it works. So this thing exists, and I'm quite proud of it was my first like language parsing project. So you can do quite some fancy syntax here. So for example, track that I worked on the ICE since 16 o'clock for the Distribits conference, give it a title that I did more foils. And it makes these boxes here. You can attach arbitrary metadata. It's just git-annex metadata. You can put anything in there. And these time slots don't interfere with each other. You can track simultaneous things, which is a big limitation of many, many time tracking systems. They only allow you to do one thing. You cannot do anything like in parallel. And so it's here. It's just pip install away. For me, this annex time log thing makes more green check marks than the other solutions. So for me, it's good, especially the tracking of overlapping simultaneous periods. And no merge conflicts. You say just annex time log sync. It basically just git-annex sync in the background. No conflicts. It just works. and this is very nice. So for example, this is what you could do with it. You can track that you work, you can stop it, you can continue it, you can say that you work for 4 hours at home with this client on that project, and you can specify times, you can search the events by metadata and by time, and you can export it to JSON, to time clock, and do the further analysis in age ledger. Of course, you can also modify data, you can remove and just sync it up. So I'm quite happy with how this turned out. It's still missing a bit of like nice presentation in a like Gantt chart style. That would be really cool. Haven't had the time to do this yet. Another fun experiment was, I think some tasks in git-annex repo management are a bit tedious and repetitive, like keeping the names of your remotes like readable. I like to to make the descriptions kind of readable. I often look at git-annex info output to see what is this. I mean, I have so many repos. I want the git-annex info output to be nice. And so renaming repositories, all this preferred content stuff, it's so powerful, but it's a bit hard to debug, I think, and to see. So I tried starting this git-annex control center, which is a terminal application, and this is my first try with this textual Python framework, if you know it. It's an amazing thing that basically makes a website in your terminal. Yes, this is a scroll bar. Yes, you can scroll with your mouse, and it's even smooth. Like, yes, you can have tabs, you can have buttons, you have, and it's like the API is really good. It's not hard to program. GUI programming is fun again with this. You can have keyboard shortcuts, dark mode, light mode. You can have like a file structure. So it's and here checkboxes. This thing is really crazy, and this is just a mock-up. But it would be really cool to have this super cross-platform thing to just ease the management of some git-annex tasks a bit. So this is maybe also something we can discuss for the hackathon. You can also just pip install it and run it with git-annex CC. It can't do anything yet, but you can click around and try this texture thing out. It's really fun. Okay, and now, as a last remark, something I just want to put out here. So there is this open timestamps thing that nobody knows about, pretty much. Who knows it? Yeah, because I posted it, right? Yeah. So what you can do with open timestamps, which is really cool, I think, is you can attach a fancy timestamp to your GPG signature. I mean, we know we should all GPG sign our Git commits, but with open timestamps, this adds another signature to this, which is a timestamp. And this means, and this is a technically very, very robust timestamp. It's not something where you have to trust anyone, which is very, very valuable. And this open timestamps thing has git-annex support. So if you have timestamped your commits, you can extract proof of time existence, so when that file was created or existed back then, for any git tracked file and also annexed file. Why is this important to be able to prove that something existed? Think of any legal situations, maybe even like you take pictures of a new apartment that you want to rent, and you want to prove that this damage really existed 3 years ago and that you just didn't take this photo yesterday. And or maybe if you want to prove that a data set really existed at that time. This can be necessary in some situations. And but I have to do a trigger warning here. It uses the Bitcoin blockchain underneath. I know some people don't like blockchain. I'm also not really a blockchain enthusiast, but I think this might be one of the only real good applications of blockchain to do this timestamping right. Yeah, and also maybe in the context of this XZ vulnerability that we all know of, had they all used, I think they didn't use GPG signatures for their commits, right? That's one first problem. And had they also timestamped their commits, And think about when the maintainer's key would have been compromised, the GPG key. The attacker could have forged signatures with this key, but if you have timestamped commits where also the GPG signature is timestamped, you cannot forge a timestamp into the past. So this is another layer of security. If you have timestamped your signature, even if the key is compromised, you can at least prove the past signatures that they are still correct. Yeah, and that's it for me. My 20 minutes are over. Thank you very much for listening, and I'm looking forward to the questions in the panel discussion.
Thank you, Jan. Time to get on the stage. And one for you guys. Yeah.
Oh,
Okay. Go there. And somebody goes here, goes here. Okay, do we have questions in the audience? Remy?
Hi. Question mostly for Julian, actually, regarding the analytical variability. One thing that your talk made me think about was maybe you had the thought and you're maybe planning to do this, or maybe someone in the audience has an answer for this, but have you considered doing some sort of like multiverse analysis using DataLad? Meaning that you have a branch where you run all of your different analysis, and then you can easily switch between branches to get this. For those who don't know, multiverse analysis would be the idea that you run exactly the same analysis, but you change a few parameters, and you just let this analysis run, and you see how the results vary depending on that.
Thanks, Remy. I didn't yet. I do think it's, one thing that I did think about a bit, because usually that's one of the motivations for having different versions in the same folder even, right? And I think that is usually something that we then hard code, like specify all of the labels or something of the different analyses. And here you could indeed think about a way in which you just have an automated switching of branches. I think the principle would actually be identical, right? And it might not even give you different data savings. The only thing that it does do is it keeps the analysis consistent, and you actually don't have a script with different file names. So I'm not sure whether it's necessary or whether it, provides any benefits, but I think you can do it in the same kind of style that you just outsource it to a different branch, just like you probably had in mind. But indeed, it just creates this other layer where you then need to have some script that iterates through the branches, but I think otherwise it would be comparable.
I have a question. Thank you for your nice talk. One comment is this EEG many pipelines thing is really funny. It's kind of meta, isn't it? Like you have data from a study, but instead of like studying that, you study the people that analyze it. I find this really funny. This is really cool.
Yeah, I think that's also the idea of the whole metaverse analysis, right? You're really looking not at the actual question that you're trying to answer, but the question shifts towards what are the procedures that we're actually using, how robust are they? And I think people are just a part of that problem. I think to give a spicy comment on this, I do think we sometimes forget, potentially because we are all really interested in analytics, that there are a lot of decisions that go into a study and acquisition parameters, for example, that you cannot change after the fact. And I think that is, maybe the more obvious one, but I think it's also something that we sometimes forget about now that we care about analytic replicability, reproducibility, that there are lots of other factors that go into it. But I think you're completely right that I think we are studying this at a really meta level and meta-analytic level.
Any other questions in the audience? Oh,
yeah,
Michael?
That was really cool. For me, this is extremely motivating, and it pointed out that I think you both made the point that there should be some sort of more communication, right? And to figure out what are the pieces? And when I listened to your talk, Jan, I thought this should all be used, and somehow should there be better networking? So my question would be, do you have any thoughts what the venue for that type of communication would be? Like, how would we better interact as the git-annex believer system or so, right? Do you have any idea?
So I think if I want to make you very happy, most times I give talks that are to a relatively broad audience. I include a slide on DataLad, and usually people don't ask me about my science, but about DataLad. So I think the interest is definitely there. I think if you look deeper, I think the real problem is, what do people actually want to use it? And I think there's a lot of communication on all of the feature set that DataLad offers and going into detail on that. And I think that hurts the cause, because I think that people run into relatively simple problems early on, and then, if they have too grandiose ideas about what they want to do, I think that can be discouraging. So, for example, I've never used the DataLad run command. I think it's a really cool command, but it also is for a very specific use case, right? If you really want the whole provenance, and I see that as the kind of end goal, right? If we have the whole system set up. But to me, for example, just versioning and data reuse and kind of nesting was the more attainable one that I could already work with the structures that I have. The other thing is, I think we need to be careful not to make presumptions about how people actually use the tool. I've noticed in the open source community, in particular, or open science community, there's a push towards, for example, being quite discouraging about people using MATLAB. And I used entirely MATLAB scripts for the EEG many pipelines thing. And so I was always looking for these general tools, such as DataLad, that can actually help me do the things that I need to do without having additional constraints on it, right? You want to make sure that that flexibility is there. But yeah, when it's about communication, I think that's the thing that I'm still struggling with. And when I teach these things, I try to present my use cases, because they were kind of logical for the workflows that I had. But that can wildly vary. So I wonder whether we might need a survey on what people actually value in there. Because even if we zoom out further, right, like this whole part of what DataLad can do is only a part of the open science picture. And yeah, I think even for me, it's tough to say what people would be most interested in that.
And to add to that, to increase the usage simplicity of this, this is also the reason why I started this git-annex control center thing. I mean, it's in the terminal, okay, but it looks kind of cool, and people are used to this. And maybe a super simple kind of GUI for DataLad and git-annex to just help people a bit enter this this realm, like copy paste a link and then hit download or create or something. I think this would help massively, and to ease some of the small simple tasks where people start to fail early on because they just don't have the experience. I think this would be a really cool addition.
There actually is a GUI. Like, it was done in a month project like a year and a half ago, and it probably kind of works. But similar proof of concept thing.
Is this GUI thing, right?
Yeah, exactly.
Is the GTK app?
It's PySide.
Yeah, but does it work on a Windows as well?
Yes.
Okay, well, right, then I maybe have to check it out.
It used to work 1.5 years ago, but
right. I think I ran into problems installing it somehow, yeah.
JB?
Yeah, there was 2 fantastic talks. Thanks so much. So impressive, I mean, for me at least. One thing that is, I mean, it's not really a question, it's really more like a call for, in that communication aspect and teaching aspect. One thing that I always recommend the students to read is the Git parable, because it gives kind of an intuitive understanding of how Git works, right? And in a very nice kind of narrative way, and like, it's a, can I have put a call for, like, Joey or others to do the git-annex parable? I think that would be a super nice piece where, you could start to link and then because when you're using DataLad, you always kind of, go to the layer of git-annex at some stage, and understanding the principles and how things are set up and things is so important for giving you confidence in the tool and a bit of ability to debug and all those things. So I think just a call for some knowledgeable people, not me, to actually develop that narrative and that training kind of a tool. I think that'd be fantastic.
And for those who don't know what Git parable is to explain how Git works without saying anything about Git, to pretty much to come up with a version control system and describe it, and then just saying that, oh, that what you come with is pretty much like what this Git is.
Put the link on Matrix.
Okay, cool. Yeah, so it's really, there is a few versions of that already written, so something like that for git-annex.
To kind of touch up on that, I think maybe both of the previous questions. I think a big one is the actual applicability to people's own workflows, right? And I've talked to somebody in the audience that were, for example, setting this up at MR scanners, and I've gotten similar recommendations at our institute that that's actually the place to start, right? That whole data consummation thing. Having people try it out with their own data structures might be the most easy way. So if data infrastructure providers, for example, in a data acquisition lab, provide you the data in two formats. One is the big one is the DataLad one, and people can choose and try it out. I think that might be the way to really ease people in and get them familiar with these tools. And that will probably take people within these institutions to make a call for it. But again, I do think the motivation is there, and people are quite excited about it. But again, that's also a very limited use case compared to all of the capabilities that DataLad offers, right? So I think that vision is cool, but I think also we do need the groundwork also in mind. And with regard to the teaching, I think people are now in our field at least moving towards also having this a bit in the curriculum, but it's always going to be also a competition with other classes that people have to take, right? And it's again coming down to time. So the more efficient the resources are that people can go through, I think the better.
If I may,
just a thought short, and on that note, this GIN thing, it really is like a self-hosted Git website that knows about annexed files. So the plots that you link there, they're annexed files, and they work when you link them in the README. That is amazing. I didn't know that.
On that topic, so you talked about workflows and different tools already. So we are talking pretty much about toolkits, right? Every workflow has a toolkit behind it. And you covered some of the tools, but what are your toolkits? Like, what is your workflow beyond DataLad and beyond timestamp? What additional tools you think, like, for me, let's say, I use Z-Shell, right? And I love history of Z-Shell feature, so I search through the history all the time. That's why whenever I teach reproducible science actually to kids, I'm saying them, first you be able to reproduce your commands, and you reproduce them by rerunning what you've run before, and that is in your history. Be efficient to find them. Never retype the same command. So, because you could search it, Control-R, you start typing command, it pops up, you run it, right? So what would be your toolkit? What would you kind of present, even collection of tools, like what you use?
You have a lot of tools.
Like technical tools in the terminal, yeah.
Names.
I mean, a terminal multiplexer, definitely. Tmux still. I hear Zelige is very good.
Zelige?
Yeah, this new kit on the block, written in Rust, of course. I use the fish shell, FZF, of course, for even nicer history search.
FZF, okay.
Yeah. Editor of choice, Vim.
Okay.
So that you can work from everywhere. And all of these tools you can adapt. You could teach some level of git-annex compatibility or with shortcuts or with commands that you write that make things simpler. For example, I wrote a git sync command that does the git stuff, depending on if it's a git-annex repository or not. Either it runs add, commit, fetch, merge, push again, or just git-annex sync if an assist is not available. Thank you again for making git-annex assist a thing. I mean, you can build your own toolbox so that you can.
That's
work.
the point. Yeah. So toolboxes of people.
I have heard none of these except for Vim. My toolbox involves Word, PowerPoint, those things. I mean, when it comes to programming languages, we actually do just mix and match tools for whenever we think they're most appropriate, right? And we take the language that they're written in and we try to learn as much as we need to employ them. So I use a lot of Unix scripts, or you know, that's basically just commands, write a few shell scripts around them, MATLAB, Python, but it's not like I'm coding entirely new tools or something. I'm just creating the interface blocks that run them in the way that I want them, right? But even at that level, so, you know, even at that level, I could still rely on GUIs in some instances, and colleagues do, right? And we think we need to be aware of the fact that people have that desire to also use these tools. So yeah, my workflows are usually centered around just writing scripts that evoke different other tools underlying it, but nothing too computationally fancy, I would say.
Okay, cool. Thanks. Any questions? Otherwise, I'll keep bombarding these people. Okay, especially, so the question in your imaging world, for me it was Julian. Oh, there is a question in the audience. Okay, let's go to the audience.
Do you know if there's some sync tool for git-annex or DataLad that kind of runs in the background and always comments if the user changes something? This would be great for a lot of things. Yeah.
There is, and it's written by the very Joey Hess himself. It's the git-annex assistant. So you can just write git-annex assistant, and it does exactly what you described.
Yeah, we use it for data, actually, collection. The system writes down video files, Annex detects that they are no longer modified, and it commits recent changes in git-annex. You can even instrument commit messages, right? So you could provide a script which will make commit messages specific to what you want to say there.
On my phone, I don't use the assistant because it uses a lot of power. So I decided to make a custom loop around git-annex assist, which has the exact same effect. A little bit less, it does, of course, the reconnecting and stuff. But basically, the git-annex assistant is a while true loop over git-annex assist.
Chris, do you want that to be formed as question you posted, or?
No, like kind of a side. It's one I really want to take what
Okay.
I just had a quick question for Jan. About the git-annex GUI that you're working on. Jan, sorry. You mentioned short names being something that you noticed, and keeping track of descriptions, UUIDs. Can you talk about that a little bit more? Because that's something that I've had a concern with, where sometimes I want to keep using the same UUID if I create a new repo on the same machine, especially if it's tracking similar data. What I do is I just have template repos that I clone from, but I wanted to know if that was something you'd thought about or anything like that.
That is an interesting use case. Reusing the same UUID always feels very wrong to me. I don't know if this is a thing, but okay.
It's the same machine for the same project, but...
Yeah, maybe if you don't want to clutter like this system with another remote, yeah.
If I want that have similar names, but just where they were created.
So there is a way to do it. I would actually have to look at the documentation, but I believe it's git-annex reinit.
Oh, I do that.
So, okay.
And it can, but then I have to go look it up.
Yeah, well. It's an inadvisable thing for a random person to do without realizing the consequences, so I think that's...
Felix?
So thanks for the talks and for the, let's say, use cases of on different levels. I don't mean computational different, but in principle what you deal with on which level. And I think my question to you is how you teach that, because I'm trying to teach DataLad enthusiastically over the last, I think, 2 years, and I come up, and I think we could talk about this in a conference or later, but what are your approaches? Where did you fail more than, or what was, where were more successful? Because it's difficult to motivate people to use it if they are not basically really motivated or technical savvy, let's say, with this. What is your experience today?
Hi, Felix. Yeah, so I tried to use the strategy, and I think it kind of worked, to actually not start with how does this whole thing work, how do I type the commands, what I did today, but actually starting with the use case, right? Like, oh, look at this, I can replicate my entire structure. This is like 3 terabytes in real life. How can I do this in 80 seconds, right? I think bringing that up and basically starting with the problem and the solution, to me, helped at least grab a few people's attention. And I think there's absolutely excellent resources out there on YouTube and so on that people can really dig hours and hours in if they really want to know how this stuff works. But I sometimes wonder whether people zone out in the details again. I haven't had much success with, I think, really having people engage with the platform too much. But I think that's also because we just don't yet have this kind of decentralized workflow. I think one of the problems that I see in science is that it is still a very individualistic thing, right? And for me, that whole structure benefits. But I think unless we move to this more decentralized flow where people actually do work from all over the world with the same resources and actually have massive efficiency gains from interacting with them, people can rsync the whole 4 terabytes over the weekend to another server if they need to. And so I think that need is important, right? If people don't have the motivation, then no matter how you teach it, you won't get through to them. But I do think starting with some of the use cases and inspiring them about what they could do with it, practically as well, is useful.
My approach is typically when I work with students, we have the situations, okay, here's some data, you want to analyze it maybe for your thesis, for example, and how do we make it that I can look at the stuff that you do without too much hassle and maybe contribute some fixes back if something doesn't work without you coming with your laptop and me looking at it. So this problem is, I think, quite common. And git-annex assist is basically exactly what this is. You have a folder, I configure the basics like Python scripts into Git, obviously, and anything bigger than a megabyte, for example, goes into the annex. And then I tell them, if you want to if you want to save a snapshot, basically, and want to sync up, just run git-annex assist. You don't need anything else. And this works quite well. And you can tell them that you can keep old versions. You cannot break anything, basically, because every version is still there and safe. And the adoption is okay. It works like this.
Okay, I think we are on time. It was a wonderful session. Thank you very much, Julian and Jan. Now we have a coffee break, I believe, for a little bit, and then let's get back at 11:45 to so 10:45. Right, 10:45. We'll be back. Half an hour.
Exchanging PGP keys. Let's meet at the coffee hall at the long.
let's continue. We are very well on time. Let's continue our great series of talks now with 3 more talks. And the talk now is by Julia Katharina Pfahl. And it's only for us, basically, so sorry for the online audience. The content, you might have access, just write to Julia Katharina. And now, let me find the introduction, sorry. I'm holed up in a lot of nice discussions on the way, so, which I really appreciate here. So Julia Katharina is part for the NOWA infrastructure project of the CRC 135 at the University of Marburg and the Adaptive Mind Consortium as data steward. The main goal of her work is to create a data management workflow, which is not too complicated to teach to researchers unexperienced with research data management. Great task, or hard task, but very important. But at the same time utilize state-of-the-art tools, concepts, and standards in the data management to foster reproducibility and data sharing. Please, the floor is yours. Is Timothy here? Yeah, great. All right. How was your trip? Did it work out? Well, at the end, obviously.
Well, I got stuck in Copenhagen. They put us on the wrong bus.
Okay.
Is there a mini? Oh, actually, no. I'm good. So.
Thanks for being here. So let me introduce you briefly. So the talk is about git-annex recipes, and Timothy has used git-annex since 2017, so a long time, for a variety of projects, from being a lab assistant at New York University processing medical data, to television production with PBS, Roku for the television show This Old House.
Yeah.
In this talk, he shares his recipes for scaling git-annex use cases.
Yeah.
Looking forward to that.
Thank you. Yeah, I come from a bit of a different background. I'm purely a software developer, and I've used git-annex at a few of my jobs, and just generally to solve some of my problems. And so I'm really thankful to be here and share some of this with all of you guys. And I hope you find it interesting. So. Just as, like from a system administration point of view, I've tried to work around some of the pain points that I've had with git-annex by just writing wrappers, and like I've never really been happy with transferring, and I think that that's something that could probably be externalized a bit, but what I ended up just doing in one case was writing a wrapper for git-annex get, and I've played around with different ways of using metadata for storing things like when something should be transferred. Some of the stuff that I started working on, Joey ended up implementing later. Like, I'll show you further on in here, but just dealing with dead keys and untracked content, stuff like that. What else? One example of one thing that I did was when I had to deal with large file sets, I was able to really optimize things by using Betterfs. I would just make my git-annex objects a sub-volume, and then if I wanted to clone the entire thing, I would just use Betterfs, and that way you can just send it. All right, let me just break this down a little bit more. With ZFS or Betterfs, you can take a subvolume in ZFS, their data sets, and you can just send it over a pipe. And the file system driver will be responsible for verifying the integrity of everything, and it'll even preserve compression. So if you have one of these newer file systems and your data is in git-annex at rest, you can take advantage of that by when you send it, if you want to move it to a different volume or a different machine. And also, I have this script git-annex scrub. All it does is it just reads the file, and if it gets any kind of error, that means that there's a problem with the file. As long as the file's generation hasn't changed, then you can safely assume that the file on disk hasn't changed. And you can even, I don't know, it's not supposed to be extent, it's extent, but an extent is just an arbitrarily sized.
Do you realize we don't see any slides? You said extent.
Oh, wait, what? Oh, God, you haven't, sorry about that, guys. Oh, so I've been presenting the whole, I knew something would go wrong. Okay.
Sorry, I thought it was a long intro.
Very good.
Okay. It was just a snippet. Progress. But yeah, just a tip, usually you should do it over SSH, and this is just an example on a closed network. I was doing it with Netcat, and mbuffer is really important, or at least pipeview, but you will sometimes have to know outside information about how to optimize it. So here I'm forcing it to have a 2 GB buffer, and yeah, it's quite useful. And as I wanted to deal with some of the issues with git-annex, that's actually what encouraged me to explore some of these newer file systems. So maybe it would be good if there was some way to make trust level smarter or something like that. Because I know that if it's on a machine where I'm having my file system handle integrity checking and stuff like that, then I can have more or less confidence in it. Oh, and I can put links on my GitHub, but I experimented with integrating git-annex into Portage in Gentoo. If you look at my overlay, my Portage overlay on my GitHub, I made a few e-builds related to git-annex. I made a git-annex bind one, which I don't even think matters anymore because Gentoo has been making that more available. But I also tried extending the, I think it's Git. I'm sorry if I'm going into if I'm drilling down too much into the technical stuff with this, but essentially I think it would be cool, and I'm going to continue working on this, trying to integrate git-annex functionality in places where it can be useful, because I consider git-annex I treat it kind of like a format, right? So we already have many cases where we have URLs, file names, checksums, timestamps, and we already have a lot of tools which use these. And so just using git-annex can actually solve a lot of these problems for you. In Gentoo, you have your dist files and you have e-builds, which are descriptions of files with checksums and file names. And so you can very easily just convert all of that into an annex. It even comes with, you can even have keys for each different checksum type you want. Like if you want Blake or what is it? Is it just, it's not called Blake, is it? It's Blake 7, I think? Something like it. It's faster. You can do that very easily. So but also, when I think about it as a format, it doesn't necessarily have to be a full implementation. Like I might just want to have just keys, and I don't need to have a UUID log or a remotes log or anything like that. Let's just go down. So, and these are just some of the projects that I've made that involve git-annex. This is something else, again, which I made in 2019. This is because my friends and I, we have a big Google Drive share. And we would only share public domain content, Linux distros, Linux ISOs and stuff. And I can just navigate to this, we can go through it. It will let you construct it's mostly based out of a makefile, but it will, you just feed it, assuming you're using rclone, you just feed it a backend path and then the URL, and what it will do is on the fly construct a git-annex repo for you, and it will also set the web URLs to an rclone web server that it starts running. So that way you can reserve it to everybody on the local network, and you have this annex that you can just take with you, which maps every single file in a Google Drive to an entry. So you can just say, if you see a
a Google Drive share, you could make an annex of a part of it or a subset of it, take it with you, and yeah, so that's one of my projects. How are we on time? Good. Good, okay, good. This is another one. This actually, this unfortunately is an example of something where it kind of collapsed under its own weight. So it lost some of its momentum, but I think it's a good case study. So I think it was on Hacker News or something. Microsoft used to offer these pre-built virtual machines for testing. It was kind of useful. And I thought, here's another place where they're giving us MD5 hashes, file size, names. And there's a lot of people in the public who are interested in knowing where to get them. Constantly you're seeing discussions on Reddit, everywhere else. Where do I find these? Where do I find them? People are passing them around. People are like, oh, I put some in Google Drive. I put some here. I put some there. Perfect application for git-annex. And someone even already started an ingestion script, but that's just up here. So I just assembled a git-annex repo around it. One issue with a lot of my projects is I was accidentally leaking information, and so I went and I deleted the git-annex branches. So, and I had my .edu Google Drive share. I had so much crap in it. But what I ended up doing was I just forked, because a gist is a repo. So this actually starts out as just these guys talking about it, and I forked it, and I annexed it, and I externalized the actual files, and if you clone it, you could, in theory, well, it probably doesn't work anymore, but you could git-annex get it, and you'll have the files properly checked. So that's, and I think stuff like that's cool. And I also, a lot of FTP servers were disappearing, especially back in like 2018. And there's a format for listing FTP servers, and it's not regular. It's not, I don't know, I guess it's just because of how the FTP protocol is. But with a bit of work, I was able to make a converter for that too, and this is just one of the example projects. This is a site that hosted Apple abandonware, and it's 1.3 terabytes. You know, it's a repo. And you know, you've all seen a git-annex repo, but it will, like the first step before I did anything else was creating the keys and the structure. And then I think in here it even shows it. You can break it. When I archive, when I mirror stuff, step one is to create the annex, and then I can use the annex as a queue. And you can even break that up among machines, among people. You can create a branch and say, anyone able to get these really big files, and you know, they can push back from that. So, also, this is another tool, and this was made using a really old version of it, which had really crummy escaping, but I made this tool called Store Touch, and it just creates a sequence of touch commands that'll let you restore the exact timestamps of a file. This is before I did proper escaping. I copied the style used by this tool, git meta something. But it's also a proper TSV file, so it's both executable, but it's very easy to parse. Let's see. Do we have anything else? Okay, cool.
I did Red Hole Radio too.
What?
I have Red Hole Radio.
Oh yeah, I forked that.
Oh, you?
Yeah, that's from DataLad. That's an example from the DataLad ingestion scraping thing. Oh yeah, this is just another one. This was something I actually really needed because I was working with some old mobile computers, and I got that just in time. Oh yeah, this is what I was mentioning. No, it's the humble little helper script. But the time that something is committed, isn't the same thing necessarily as the M time of the file. Let's see what else. Oh, yeah, and again, like one of my bigger repos, which was just video files, I made this script. In my experience, it is faster sometimes to just, what it does is it just takes a folder in your repo and it copies out all the keys and it just constructs an entirely new repo from what you have. And the reason that this is useful is because you can, I call it like a satellite repo. You can do what you want with it. You can put it even into an untrusted location if it's just pulling and ingesting, if it's just ingesting data and then pushing it somewhere and updating itself with information about where that is. And then because of how the merge driver works, it's very painless to just pull it back in. So that was the pattern that I used for quite a while. Like if there were any YouTube channels I liked, I was just continuously mirroring them. And so I had this 37 gigabyte git-annex mono repo. And oh, yeah, so another utility that I like, I don't know how many of you have heard of it, it's called NCDU. It's just a tool, I probably have it installed on here. Not the same screen, okay. But if you use, it creates a listing of files and in a JSON-like format. And for one thing, I wrote a wrapper or a git-annex helper that just pipes the output of whereas directly into NCDU. Let me see if we can get the terminal up here, which is actually pretty helpful. And I'm going to bring a terminal up so I can just demonstrate it. But and the other thing that I listed in the abstract was fully leveraging BUP, which is very similar to Borg, and I should probably use Borg. BUP is just what I started with. And it just lets you make different, it lets you take sets of files which are very similar to each other, and it uses Git, it makes pack files. And so you can really leverage differential compression with it. And the way that I combined it with git-annex, I mean, besides the fact that it has the same limitation as Git, which is that there's no way to tell where something is. It is either there or it isn't. So I monitor servers, and I have NCDU generating snapshots for me continuously, and they're very similar to each other. And if I just tracked the pack files themselves, it would just get bigger and bigger. So you can seamlessly divide them up by category, like by year or whatever, and then regenerate the pack files, and they're all associated with each other. So I can go into detail about any of this stuff, but yeah, that's where I am. I think there's a lot of really cool stuff that can be done with git-annex, and yeah, and it's cool, yeah.
Maybe there are direct questions on anything. Alex?
So for the portage dist files, I mean, it sounded like you created an e-build for git-annex itself, but I'm not sure if I completely understood what you were talking about. So I think what you were saying is that you wanted to have, like, you would emerge something to install it, but then you would have git-annex end up pulling down the assets that were necessary in order to be able to compile and install something.
Yeah, I did a couple of things. I created a help. You can have it so that you can use whatever program you want to fetch something. So I had a wrapper for git-annex, and my dist files folder is actually a repo, so it will implicitly cache it. But Also, there is an E class in Portage, which, you know, when you have, if you use Gentoo, there's a -999 E builds. Those actually do git clone. I started modifying that to do what you said, to see if it could use git-annex to fetch something instead. And so that was quite a rabbit hole. I don't know if it's realistic that any of that be finished, but it would be cool.
Was there any uptake on it? Was anybody else using this as well, or just a hobby?
No,
so
just
far?
me.
Okay, I think it's a cool idea. So.
You can. A lot of this is on GitHub, and I'll make sure to put anything else up there. But yeah.
Thank you.
Yep. Yeah. Oh.
Just quick one. So that transfer of BetterFS. First of all, BetterFS or ZFS? What is the choice?
First of all, someone tell me. I call it BTRFS in my head. I never talk to people about it. Some people say it's BetterFS. Some people call it ButterFS. If anyone has a preference here, I'm saying BetterFS.
Me too.
Yeah. Oh, but ZFS, every time I talk about it, people are like, but ZFS is better, and I'm sure it is. I just haven't had a chance to try it yet. And BetterFS works out of the box on Linux, and it also is a much lower learning curve. You can use it exactly the same as you do ext4, but you can also start using the more advanced copy on write features and stuff like that. So it might be a better choice for you if you want a more advanced file system and can't commit to learning ZFS right now. Oh, by the way, if you look on my overlay on my GitHub, you should be able to see in one of those branches some of my experiments with the integration of git-annex with Portage. Okay.
All right, let's give a round of applause for Timothy to show us that we have to move on. And we have some time for questions later. Isaac, please. So the next talk by Isaac Tour will be on the DataLad registry, bringing benefits of centrality to DataLad. And Isaac is a software developer. He joined the Center of Open Neuroscience with Jarek at Dartmouth College.
I did the USB.
Oh, is there a
USB-C
USB-C converter adapter? So he joined the Open Neuroscience, Center of Neuroscience in 2022. And his role at CON, Isaac focuses on the DataLad registry, aiming to bring the benefits of centrality to the DataLad community. So the floor is yours. Thanks.
Oh, it's right there. Sorry for the delay. I will talk about DataLad registry. Jarek actually directs this project, and he will assist me in answering some of the questions later on, especially the ones regarding future developments. Before we start, I want to thank Kyle, John, and Stefan for their contributions to this project. The funding for this project comes from DataLad, Dandy, and Rabulim. We have a few goals for this project. To discover DataLad datasets and Git repo touched by DataLad runs on the internet, locate reuses of these datasets, make up to date dataset metadata available, and also enables search of dataset through their metadata. We accomplish these goals largely through automation. DataLad DataLad registry automates discovery of datasets, extraction of metadata from datasets, and also update of dataset state and metadata. And given the vastness of the internet, even a robot would have difficulty of picking out datasets from it. So for the discovery of dataset, we rely on an existing project, DataLad usage dashboard. It's developed by and maintained by our team member, John Water. It uses GitHub Action CI to periodically search for DataLad, related repos on GitHub, OSF, and Gin. It compiles a JSON file with all the discovered datasets. Currently, the registry have up-to-date information on over 12,000 datasets. This dataset consists of all those on dataset.datalad.org and all those discovered by the usage dashboard I just mentioned, except the ones residing on OSF, which are to be added soon. Various extractors are employed to extract metadata from datasets. Some of them are generic, while others are domain-specific, like the one for BIS dataset in neural imaging, and Dandy for datasets in the Dandy archive. So this is the current web UI for dataset registry. It's a collection of datasets displayed in tabular form. Each dataset is identified by its URL. The dataset column provides the UUID of the dataset if it happens to be a DataLad dataset. Last column lists the metadata of a dataset extracted by different extractors. Other columns provide some basic information. In this UI, you can access the search functionality in dataset registry and the documentation of its search query. Each simple string, a search of a simple string is a substring search across all the searchable fields. Particularly, in this particular example, shows the mandatory substring search of Haxby, who happened to be the original mentor of Yarrick and Michael across all the searchable fields. A substring search can be restricted to a particular field, and logical operators are available for constructing more complex search queries. UUID in this particular example is the ID of the ReproLim container dataset. This query demonstrates finding all the datasets that reference the container dataset. A close approximation of finding all the dataset that uses the container dataset as a sub-dataset. Of course, this particular behavior is to be improved, since it's just an approximation. A search can be restricted to metadata by a specific set of extractors. The query in this example locates the dataset conforming to the BIT version 1.6 standard. Beside the UI, dataset registry also provide an API. The schema for the Open API schema for the API is available for download, and with it you can use Open API generator to generate a client to interact with the registry. Additionally, interacting with interactive documentation of the API is available through Swagger and 2 other interfaces. So supported operations in this API allows registering of the new data sets through, it allows registering of new data set, although this particular feature is currently disabled in our public-facing instance. Querying of the data set based on restrictions, and fetching data set and metadata by internal IDs. In particular, dataset query, the dataset query endpoint supports the same search functionality as the web UI, but allow for additional restriction on in a search, and provide an option for including metadata in the search results. A fully featured DataLad registry instance is made up of a few service components. A web service that serves the UI, the web UI I just pointed out, and also the API endpoints you have just seen. And also a database service that stores all the metadata, and salary-related services that implement the automation that I mentioned earlier. In particular, the worker is responsible for doing all the cloning and the metadata extraction. The scheduler is responsible for doing initiating periodic tasks to be executed by workers. These periodic tasks include the syncing of DataLad registry with the DataLad usage dashboard for new datasets, and updates of the updating of the registered dataset and also their metadata. The registry can also be launched as a read-only instance that consists of only the web and DB services. Such an instance protects the fully featured main instance from abuse. Multiple read-only instances can also speed the workload. Read-only instance is set up of is set up to be in sync with the fully featured instance always. In fact, the instance that you interact with at registry.datalad.org is a read-only instance. Now, DataLad registry is far from complete, at least that's what I hope. Currently, we are trying to integrate DataLad registry with DataLad catalog to provide a landing page for individual datasets. We will improve search by allowing search in specific JSON fields in metadata. We will also export metadata to a graph database to allow search based on knowledge graphs. We will add dataset level metadata from extractor that are not yet included. We'll also do file level metadata extraction. In pursuit of all these, we anticipate scalability to be the main challenge, and deciding on the right database technology to use seems to be the crucial step in overcoming this challenge. And if you guys have any recommendation in what graph database to use, please let us know. If you have any collection of dataset want to run some periodic tasks on, or if you want to have your own instance of DataLad registry on some private datasets, have interest in doing any interesting metadata extraction, or have some specific search use cases to address, please let us know. And thank you for your attention.
Thanks, Isaac. Actually, DataLad registry or the DataLad dataset which you can install, DataLad install ///, you got to try that. It's 500 terabytes, and that's where it's based on, and it's amazing that you can directly access most of the data. So are there any questions for Isaac?
Well, you may have addressed part of my question, which is the 500 terabytes. I was just wondering how many, what does it all sum up to? The total size of all the data sets that you're aware of?
So all those include, so what you just mentioned is the dataset.datalad.org, right? We also have the one that we found on GitHub, and also ones in Gin. If I remember correctly, it's definitely about 500 gigabyte, or a little bit beyond.
Terabytes?
I mean, just the cloning.
Oh, no, I was talking about the annexed data, not the size of the Git repositories, although that's very interesting. But I meant the annexed data that these data sets are pointing to.
Well, it's more than what you have in dataset. I mean, dataset.datalad.org, but I don't know the exact count at this point.
We should sum up on that column.
Yeah,
so we have a
right.
column, and the
That's what I would like, yes.
So there's some limitation on our UI currently, like the one you see, the web UI. So one of the, actually, I forgot to mention, is that we want to integrate what we built for the API to actually build another UI on top of that. So right now it's far from complete, just as I mentioned. So there are, there are many other information we can include, but it's finding it difficult to just include it in one single page app. So that's one of the things that we need to change.
Thank you for the talk. I find this a great project to make it more centralized and get the overview, and also to scrape data from GitHub and Gin. But just having the metadata does not give us information if the annexed data is actually available, right? So I wonder if, and if it still exists anywhere. So I wonder if there is a way to check how many of these data sets are actually still valid and usable, because the annexed content is somewhere there.
I think that we can, so one of the things that we are going to adjust is to do file level extraction, right? So when we do that, when we get to that particular point, then we can build something that also catalog if all those remote data are in existence. So when we run we will use something like a DataLad fields to actually, we are planning to use that to actually run some extraction on individual files. And then since we will be accessing those files, and we will know if those files are still in existence. So, and the other thing is that, at least that is concerning the remote data, right? But then at least each time, since we are constantly updating, checking if there's new commit, you know that if you go to that page, you see that the last time we updated that particular data set, and you know that at least at that point, someone have recently updated that particular data set, right? Even though it's not an exact timing. But we know that last time when we run that particular update, someone has just pushed an update to that. And by the way, that actually there should be one, we are planning to add one column that indicate the latest commit. Actually, it's just our oversight. We currently need there's a column, say the last change date is actually the last change date by our server that we detected a change, instead of the last commit by the user. So we will include something like that on the UI as well.
All right, let's thank Isaac for his talk. And let's start the panel discussion. So I would ask Julia, Timothy, and Isaac on the stage, please, to discuss different views, I would say, in different use cases. It's a wide variety this time, really, from the trying to get people to use it, individuals that use it, that use git-annex in a variety of ways, and the implementation, the centralized implementation of a decentralized tool. So are there any questions for all of them, for individuals to discuss?
For Yulia, you were talking about how originally there was this DataLad gin component to the infrastructure you had built, and that eventually this was too complicated, so you went for a simpler model, but that some people were indeed using gin and DataLad. What happened to them?
Yeah, so like I said, I mean, they can continue using DataLad, but they will eventually have to transfer their data to the GitLab then.
Okay, so they just have no choice.
No, we
okay.
have to.
No, it's fine.
No,
because,
I mean, we have to shut it down because we just can't then like handle 2 instances and maintain them. And then if something goes wrong, like at some point, the version of Gin we have is not compatible with the version of DataLad anymore, or something like that. So that would not be good for them.
Yeah, that makes sense. Thank you.
Yeah.
I will point out, luckily for them, they can just use the fact that git-annex can store data in a GitLFS repository, so they can then store it there. I actually wanted to comment on that too. I think, you know, for example, I follow people who do game development. They all use GitLFS, and they use it for very specific reasons. They need the ability to lock a file and say, I'm editing this image, you know, I'm an artist, I'm adjusting the art here. I don't want anybody else to be messing with my art with this file. So I think that these, you know, there are all these different use cases, and it's really important to meet the user's use case need. And so I appreciate hearing too much complexity, move to something simpler. I think it's very reasonable.
Yeah, also to Yulia, first of all, it's impressive what you're running there with the resources that you have. And I can tell from experience that just getting the PIs in a room doesn't solve the thing. And the only it makes it worse. Yeah, but and I think what resonated with me is, and it's great the way you reflect on all of this, and the demand aspect, like solving an actual need that was also expressed in earlier talks, is from my perspective the only thing that works, right? And so I think what you did there in order of to assess the situation, that would be nice to see on the outside, because like in all the plannings of all the similar information management projects in other CRCs, they all have the same problem, and I would suspect that the infrastructures being built have some sort of cognitive dissonance compared to the needs. And I also have a question, which is when you settle on GitLFS, how do you deal with something needs to be deleted in LFS? Is that, do you know if that's still a thing? Because I think that was the problem, right? You can't delete things.
Well, can't you just create it? You have to delete all of it? Right? Like, I don't think that's what you're officially supposed to do, but I have had repos that have had LFS content, and if you delete the whole thing and then...
Yeah, right. But so that's also the recommendation if you look on the GitHub documentation, right? But what we're talking about here is there's a central instance, which is the instance of the data, right? And if you want to delete a thing, you would have to have another copy in order to recreate that. And I think that's an infrastructural challenge.
I don't know how to deal with that yet. We actually don't expect the researchers to use git-LFS that much because, like I said, the people that are dealing with big data, they, it's first very few researchers, and those actually wanted to use DataLad and stuff. So I think maybe it's just easier for them to like keep doing that. And so I don't know how to deal with that yet. Stefan, do you?
Yeah, to my knowledge, git-LFS has a mechanism that frees you of data that it considers to be old, like data that is not in a currently checked out branch and is older than some criterion that you can set. And those data you can kind of drop, but it's not quite the same. So it's lacking a bit of these sweet features that git-annex has. Yeah.
So Timothy, you had mentioned, basically you're talking about trust. Well, you're talking about using, like ZFS or BetterFS, and you said that maybe git-annex's concept of trust levels needed to be increased in some way. So I was curious it's either trusted or it's not particularly trusted is the current distinction. Do you have a further distinction there, or?
Well, Oh, right. Sorry. I think it goes along with how FSCK works, and I think the simplest solution, because you're right, it should be either trusted or untrusted, but it might be good to expose that. So maybe on a per machine or per repo level, you could have some kind of helper script that could check and see what the conditions are.
You're thinking like a dynamically, like if it's hosted on this file system, I trust it.
Well, that gets even a little bit more complicated, which is why, because I looked into that, and you have to make sure that, because both of those file systems it's not guaranteed that they've actually checked some of them, and it's not so you have to double check some things, but that's why if that git-annex plumbing were exposed a bit more, then that could be doable. Okay. And also like, with something like a trusted cloud hosting service, I can just check that the file is there and it hasn't changed. It's good enough for me that, like, I don't think it's going to be deleted necessarily.
Right. I mean, I don't know if people are really familiar with git-annex trust. I don't know that it's something that people here use, but the key thing is that you can't delete it behind your back. You can't have, in a distributed situation, you can't have, over here, it gets deleted from the trusted repository, and over here, they're trusting it. So they delete their last copy of it. So I don't know if it matters if it's on ButterFS or not. You could still have that situation, right? I was actually wondering if it was more like a num copies kind of thing. If you're having, at least ZFS, you have a RAID kind of situation. So you kind of might say you have more than one copy of a file.
BetterFS does too.
Okay, so yeah, so I was kind of I've been pondering this, should maybe some of these situations count as more than one copy question, and
Every time I've thought about it, it ends up getting a bit complicated because when you do a fast FSCK, the git-annex there is still only just checking the existence of the file, and you could record when it does record when the last time it was fully checked was. I would say if there's one thing that could really help, it would just be to add a little bit of flexibility to that, and then that's all.
All right. Just there was a comment from the internet to the GitLab LFS instance that GitLab can remove files that are unreachable, basically, but there's no solution really to splitting data about different remotes, and that's what DataLad is actually doing, and other solutions. So there was another question?
Yeah.
Please.
Yes, regarding Git LFS, I think not being able to delete stuff from LFS is a GitHub-specific thing, and you can do it in GitLab, but it's more like removing stuff from the Git history proper, so you have to rewrite the history. And I have a question to Isaac. How easy is it to get into this DataLad registry with your own sort of repository? So we have a service which is similar to Gin. It's Gitty with git-annex support. How easy would it be to get indexed there?
I would say that it's extremely easy. So if you check out our repo, and basically you can, the current description is basically allowed, because it's still in, I would say, the beginning of development stage. We only put up instruction for setting up how to test the project, and also how to do it in development mode. But actually, if you just twist a little bit, is going the development mode. Just make sure that you set it instead of development mode. Follow the exact instruction for development mode, but then you do it in. Make sure that you set instead of development, you set the parameter for production. That's basically it. It's just fire up all the Podman container. We use Podman, but actually, if you want, you have root access, you can use Docker container. It should work as well. So, just basically Docker compose or Podman compose, and then bring all those. Just specify the compose file, and then all service will be up. And the only thing you need to do is just adjust some of those parameters in environment file. For example, your secret, the password and stuff like that, and you should have it going in no time. If you have any problem, just send us an email or file an issue.
Did you want your own instance of register, or just? Did you want your own instance, or you just wanted to register your URLs to our instance?
In your instance. So.
Oh, okay. File an issue against DataLad usage dashboard and say where they are and how to discover them. So we'll add it to DataLad usage dashboard, and then registry automatically would pretty much pick it up, I would say.
Yes, currently is that we don't allow the function. If you run your own instance, you can register your own URL. For example, if you have something that is not data set that's not, you don't want to disclose to the internet or the public, you can run your local one. You just run it locally. Okay, even file directory you can specify as, like within the same machine. So the registry will do the extraction for you, and all those cloning and keeping any update will be, reflected in the instance.
If you wanted to have your own instance of the catalog, how easy and what would be the easier way to actually implement something that does access control? These users can access those data sets, these users can access those data sets. what will be the framework for that?
Are you talking about registry?
Yeah.
I don't think we currently have that support yet, right?
No, I know. I'm just thinking ahead. If you were to add a layer on the top of the registry that does this kind of service, do you think there would be an easy way of implementing that?
Yes, eventually we plan to add something like that, but currently it's not. At this point, it's not our priority.
Hi, same thing in the same vein. I think it would be really useful to have this kind of personal dashboard almost of all of the kind of DataLad projects and subdirectories. And I guess it would work with what are they called, sub-data sets as well, right? You would just see them in a list if you, for example, have a private instance. Yes. And I was really struck by your one screenshot where you had this overview of, I think, just queries of file sizes and so on. And I actually thought it would be great to have, if for example, you take a heavily modularized data set, to have a template where you say, okay, I would never want to encode anything larger than this. Give me a warning, or at least give me some information. I know that you, of course, have the specification file where you say, okay, anything that is larger than this goes into the annex or something like this. But I think that's also quite obstructed, right, to the end user. You really have to go into these files and look at it. And I actually like this web interface of saying, you know, how big would you like to have the files be? Like basically you create like a specification sheet on the web or something like that, that is true for the whole project or for all of your projects, and then that automatically gets taken in.
Are you talking about like searching for particular one that within a particular size, or are you talking about?
It's basically inverting the thing, right? So you're basically having a query. I'm pointing at nothing now. You're basically having a query, but you could also just take that in as a kind of read-in form, almost, the stuff that you have designed, to set up just the specification files in the first place once you're creating the data set, right? So I'm really thinking of it in the broader context, also zooming out a bit, as a kind of dashboard, right? Where you can inspect what you already have done, but you can also start planning your upcoming data sets that you want to create. Okay. Just an idea. But I think it's really cool, and I think it's really useful. Thanks.
Thank you.
Any more questions? Maybe you have questions as well for the others. Feel free.
Yes, just we are still in the initial development stage. So if you guys have any idea about where do you want this project to go and useful to you, please let us know.
To that, Isaac, perhaps I missed it, but have you considered incorporating license information somehow? And if yes, have you thought about a standard to parse in adding license information to the data sets? Is there some kind of recommendation for license information on DataLad data sets?
I think I would defer that particular question to Jarek, since he's the one directing this project.
Different dataset level formats, right? Standards, they mandate where to place the license, right? So let's say in bits, I think we have license file right there. I don't remember if bits validator reads it out, but it will be a job for some metadata extractor. And you could create your own metadata extractor, which say, you know, license gatherer, right, of some kind, which will extract, like given a data set, I know that I should look for a license in those locations, I parse them out, and you load that into the JSON record, and then it would be visible right there. So you just need to create that extractor and give trigger points like when to run it, if it finds license file, let's say. And then it will be automatically gathering it. Different systems have different locations where to put those. Let's say Debian package will have Debian copyright, right? So again, it's a job of some metadata extractor. Registry has nothing to do with it. You create that extractor, place it into some toolkit, we include it in DataLad registry to load it, and that's an extractor for metadata. Make sense?
Very flexible, yeah. Maybe on top of that, the schema that I mentioned yesterday has places to do that. So if you have an SPDX listed license, I don't know if you know that, there's a long page that has all the sensible licenses, and so you can simply identify them this way, and then it would go through the pipe that Jarek just mentioned to end up in the registry. On top of that, if you have more complicated things to explain, there is the open rights description language. It's also a W3C document where you can say things like, this group of people are allowed to do X, Y, Z with this parts of the data set. So it's fairly comprehensive.
So Timothy, I was wondering, since in your introduction, you said that you had worked on This Old House, which I don't know if people here know the TV show. It's fairly famous in the U.S. Bob Villa. Yeah. So what's it like to work on a TV show and use git-annex in some way? I mean,
well, we handled all of the video processing for. from the closed captioning and metadata for syndication all over the world and on all of our different channels. And in terms of git-annex, it was, and in terms of a lot of it, it was just, I solved the problem. I would have loved to have integrated the rest of IT with that more. And I would have loved to have been able to, internally I did set up some pipelines. I would have loved if more could have been done with that. But yeah, this old house was really interesting. I got to meet everybody except Bob Vila. He retired and he doesn't, he's not involved anymore. But I worked in Connecticut and the whole house, it's filmed in New Hampshire. And yeah.
So what kind of problem did you solve exactly?
Well, one problem which I used just Git for was closed captioning and metadata. That was done by interns, and there are huge fines for getting that wrong. And what I used git-annex for was we had very big files that needed to be processed, and just keeping track of where they were, and stuff like that. And making sure that there was integrity. You would think that there would be more integrity and verification, but even in a business, the incentive is always to make things as efficient and cheap as possible. So sometimes you would have a big file on an HFS drive, and it would just have bit rot, and so yeah. They got acquired by Roku, and I believe they cut things even more after I left.
I have another question for Julia. The teaching material you were relating to, my question is, how did you set it up? Did you base it on some of the DataLad stuff? And I would say let's share what we have on teaching, because it's a hard job, as we heard from different people, and I think the collaborative effort could really help.
The tutorial for DataLad, I actually didn't really finish in the end, because then we just made this one-on-one support with the people who actually were using DataLad, and with the other stuff like Git and GitLab, I just based it on all the YouTube videos that are already existing and just like put together what I thought was important for our researchers, and like I don't know, told a story around it that related to their work, but basically, I mean, everything's there. So, but it's all on our Nova website and accessible for everyone at any time.
Yeah, thanks. I mean, it's really hard. I think it would be interesting later as well, maybe the conference, to get the people that are trying to teach it and maybe fail or not fail to get together. I said that already, but I think it's very important. Are there any other questions to one of the panelists? If not now or in public, feel free to just approach them, as everyone here. I mean, you know that already. Thanks for the session now, and let's have some lunch and keep on talking.
Everybody, and welcome after the lunch break. I hope you've enjoyed it. I hope you are all refueled and ready to go with our post-lunch session. We will have 3 speakers and 2 talks. The first talk will be by Markus Katharina Brechtel and Filip Kaluza, and the title is Reproducible and Replicable Data Science in the Presence of Patient Confidentiality Concerns by Utilizing git-annex and the Data Science Orchestrator. Markus Katharina is a developer and team lead in the research group of Professor Janne Wereschild, building research infrastructure for the German network of University Medicine and the German Center for Infectious Diseases. Filip is a diploma informatiker working as a freelancer. They have been using git-annex for over 10 years and are happy for the chance to deploy it in a scientific context. Since this is a talk that will go into multiple facets, we have scheduled 40 minutes for this talk, so it's over for you.
Yeah, thank you. I'm going to give a really quick outlook. So we're going to talk a bit who we are. Thank you for the introduction, but we want to tell you guys a bit where we're coming from, who our customers for this project are. We want to introduce a somewhat formal problem statement. And then after that, Markus will tell you a little bit about the architecture of the data science orchestrator. Sorry. And I will introduce our core concept there with a reproducible execution environment. At the end, I'm going to talk a little bit about the next steps that we are hoping to take in this project. I'm Filip Kaluza. I graduated from Technical University of Brunswick in 2010. And have worked in different capacities since then, but mostly as a freelance IT consultant. I do development, security, system administration, so what we call nowadays DevSecOps. I'm also a Debian maintainer, though not very active at the moment, and have been using git-annex since about 2012. I'm going to hand over to Markus, and he's going to introduce himself.
Yeah, thank you, Philip. I'm Markus Katharina Brechtel. I focus in my work on digital research infrastructure building. I'm a team lead in the DevOps team, secure research platforms of the research group cohorts in infectious diseases and cancer research from Professor Wereschild at the University Hospitals Cologne and Frankfurt. I'm also a member of the German Center for Infection Research and also other stuff. I do a lot of projects. And especially relevant for this talk, I'm a member of the DZG Working Group Research IT. So this is also a sponsor for this work, the DZG Working Group Research IT. Our goal is to make research data accessible to enable research on major public health issues. So what are the DZGs? These are the German health research centers. There are 7 that focus on major diseases like infections, diabetes, cancer, or Alzheimer's. We are a working group that consists out of developers and scientists from these institutions, and we collaborate on creating the solutions together in a collaborative process. So this work is based on this research group a lot. Genau. So part of this working group is, and especially relevant for here, is the so-called data science orchestrator. The original objectives when we started the projects have been that we want to provide a web-based analysis environment to researchers where the data does not leave the institution. This is important because we're dealing with patient data. Philip will talk about this a little bit in detail. Shortly, the creation of this environment should be pretty easy. Like the researchers don't have a lot of time, so they should just be able to apply to this, and it should be provided for them, basically. Results of analysis should be back transferable to the institution, and analysis should be able to run in different organizations. So this is especially important when we have some multicentric studies that are conducted in across multiple institutions. Yeah, so the oversimplified explanation of what we're trying to achieve, like before and after. Before, the data and the code is on the scientist's computers, and there it runs. The analysis run there, the code is there. Also, this does not enable to process highly sensitive data because they are not allowed to be on client computers. So yeah, it's not an ideal solution. It's not reproducible. It's kind of insecure. Depends on the actual setups, but yeah. The after, what we are trying to achieve, our target state is we want to have a virtual working space for the scientists on institution servers where the data does not leave the institution. So to say, we want to bring the algorithms to the data. I've heard this sentence a lot recently, so yeah. So Philip will talk a bit in detail about our problem statement that we came up with for this specific problem.
Project, yeah. Markus introduced the German Centers for Health Research, the DZGs, which itself each contain multiple hospitals, university hospitals, that kind of thing, other medical research centers, and so this is a very federated structure, and they have certain needs. So in general, most of you will be familiar with these FAIR principles, so just some standard principles for reproducible scientific research. Research needs to be findable, F, accessible, A, interoperable, I, and reusable, R. There's pretty broad consensus across scientists for this. So you might have heard the term open data in the research context. But we are dealing with medicine specifically, and we have a complication there. There's a long history in medicine going all the way to the Hippocratic Oath that the doctor should have confidentiality or agree to a confidentiality across what he learns about the patients. And it means there's a certain expectation by patients, not everybody, but enough patients that to have a wide study participation, you need to guarantee a strong discretion, and as strong as possible is always good. Additionally, if you just say, okay, I'm going to collect the data, but I'm going to pseudonymize it, so delete the patient's name, just give the patient a number, them a number. The problem is this is often revertible, so sometimes not even the birth date is deleted of that data. Also, think of somebody with a rather rare disease, and you still have their postal code, which you might want to have to look at certain cohorts, living conditions, etc. But now this pseudonymization can pretty trivially be reverted because you only have one patient with that sickness in that postal code. And so that leads to a conflict in publishing. So on the one hand, you want scientific reproducibility of your work, but on the other hand, you want to reduce the risk of deep pseudonymization. The FAIR principles introduced the word reusable. So what exactly do we aim for in the scientific context? There's a very good book, I think, The Turing Way, a handbook for reproducible, ethical, and collaborative research. And I allowed us to copy this matrix because I think it is pretty good. So you can differentiate between doing the same analysis or different analysis and doing it on the same data or doing it on different data. So the two cases of reproducible and replicable, according to this matrix, is what we're mostly interested in the DSO project at the moment. So how do we solve this conflict? Of course, we need to compromise somewhat. Internally, we've been calling this fair light. Other institutions have other words for it. Other publications phrase the problem somewhat differently, but in general, fair, the four principles are good, but accessibility, we need to somewhat condition that. So basically we say, okay, the raw data that is collected in the hospitals from specific patients, access will only be granted where it's absolutely necessary, and the person, the data scientist needs to be vetted. Reusability, so meaning we collected some data, but we want to use it for different statistical analysis. Also needs to be reviewed, usually by the Use and Access Committee of the hospital that collected this data originally. Okay, I'm gonna skip the quote. So, can we do better? Well, in IT, and if you guys are familiar with the Debian project, you've heard about this. We have this concept of reproducible builds for code. So have a confidence that that code that I just compiled is the same result of the code that somebody else compiled sometime in the past. And you need to work or engineer your environment to allow for this kind of confidence there. And we want to in the DSO project, we want to do something similar for the data analysis, which means we need to have reproducible builds of the data analysis environment itself. And how we do that? Do we do that? Of course, with lots of Merkle trees, as might come to a surprise if you guys are attending this conference. So we basically said, okay, let's put git-annex at the core of this. Then we want to build that trustable aggregation and execution environment. One of the key tenets is this, once the analysis is defined and can be run, it can be rerun in basically the same execution context. We want to keep very good records, especially what code are we running some analysis on, but also on what data exactly. And we want to have a machine-readable form to document policy decisions regarding this by the Use and Access Committee, for example. The side effects of this are that we can do partial data blinding, so a data scientist would publish their code fully, would publish the data checksums, and would publish statistical aggregates. And with this stuff in the original publication, somebody who is later granted the ability to process the raw data again can have a high or should be able to arrive at exactly the same results. It also leads to diffable code. So if the Use and Access Committee has said, okay, this kind of analysis is okay, and the Ethics Committee has agreed this, we can do this analysis on this code, and now somebody else wants to improve on that, we can review diffs. And because of the automated policy decisions, a lot of reauthorization doesn't need to happen or can happen in a much smaller scope. So, and another thing, because of this federated structure of the DZGs, that where we're trying to implement this, it means this analysis can run in a federated manner. So if a hospital participates in this data science orchestrator framework, they can run code units and don't have to give out the data that they collected themselves. So I thought I'd throw a little slide in there, what's different to what you guys are doing, because we've heard quite some different use cases over the last 2 days. I feel like for us, somewhat of a difference is that we don't use git-annex to ease data access, but we restrict it using git-annex, but hopefully in a way that leads to better research and better practices. We're not concerned with high performance considerations at all currently. Might come in the far future. And we're trying to solve the social problems. On the one hand, the problem of the data researcher, undergrad student having private patient data on their personal laptop, and on the other hand also the social problems that stem from having this very federated structure with different centers that are doing policy decisions. Markus will tell a bit about the architecture.
Let me give a few words first about our architecture. So this is kind of a complex deployment story we have here, because we have a lot of components. I will give you kind of a tour through the whole architecture. We will go from the beginning to the end. And what's a general thing here, we want to build reusable microservices that are kind of flexible to use, because in the institutions we have, and also in the use cases, we have kind of differing requirements. Some projects might need federated analysis, some might need to have specific deployment scenarios that need to be that we need to take care of. So this is kind of the use case for the reproducibility that we're currently, that I want to show you now. And every rectangle in this coming slides is to be supposed one microservice, one container basically in a one or less deployment scenario. So let's start with the image factory. This is kind of the distribution of software and code. It's kind of a Linux distribution, Debian derivative, in form of a OCI container. We have some normal stuff here, Git repo with all the code. Then we build an OCI image from it. We do some security reports. This is pretty important because we want to make sure that there are no security problems inside of this. There are no viruses. It should be like from the current known state, there should be no problems inside of this code. And then this gets reviewed, the security reports, and then we do a version release. There could be different variants for this data science images, because we might have different use cases. For now, we want to build one big image that kind of solves most of the use cases we currently know of. So we don't have too many variations there, but it is possible to do variants here. So let's take the next. We want to view inside of the institution. This kind of builds up. There's a lot of space left. This will fill shortly. So at first, our researchers request an environment. This is just a simple web service. They can fill it out. From the context here, this institution is an internal network there. So I don't want to talk too much about policy. This is more about the IT architecture, but we can say that this is basically not accessible from the public. The request might be redirected from somewhere else, so there might be something in between there. But the management service is kind of the interface where they can manage this whole requests. And then we have the institution data manager responsible for the process. They can approve the requests and document the decisions from the use and access committee there. So what decision led to approving this access, basically. But the use and access process itself is kind of a different problem that we don't solve here. So what happens next? So when the request got approved, we get our executor comes into play. The executor looks for approved requests, and when they occur, then it will start deploying the execution environment. And for this, it pulls the image that we created in the image factory and spawns our reproducible execution environment. This reproducible execution environment consists of different components. First, we have the actual environments. We have an interactive environment that is accessible by some web console. For example, JupyterLab, RStudio Web, or some other web-based IDEs are possible here. Then we have some local repository store for all the data that is handled inside of this environment. We have some dataset fetcher that is possible to go to our store. I think I forgot the right side. So at every institution, we have primary data systems. So this is the systems where the patient data is stored. This might be routine data. It might be data that's conducted in form of a study. It's very diverse, image data, lab data. So what we propose here is that these primary systems, there are ETL pipelines that extract this data and stores it inside of a git-annex repo. So this data is archived and accessible inside of this institution for this purpose, and also stored long term, basically. And these pipelines, they do that. And so we have this repository auth proxy. So this reproducible execution environment is kind of a firewalled and computationally isolated environment. And it only has two entry points. The one is the WebView console, and the other is the repository auth proxy. This repository auth proxy basically makes sure that that only policy-based access to the to repositories is possible. And then we have this WebView security console. This is something we researched for, so we looked into a solution, kind of what we're looking at now to implement is to do something like this. So we have a virtual screen and a virtual WebView application that is able to access the secured web services. So what we are doing here is we in the browser the user sees what the application is. Then this gets to a web server that's to a web browser that's running inside of the this security console, and then they only get basically the images of this web. And also only the inputs from the interactions, like the keyboard and mouse clicks, are put back to this environment. So we have some isolation here. This is kind of the proposed architecture. I won't go into too much detail about these components. It's all open source components, but yeah. And one additional feature here would be that we are possible to create an audit log of what's happening there. We can basically create a video of what every interaction can be logged and audited. Okay, then. So then the researchers have the possibility to interact with this environment. They can do some explorative analysis here inside of this interactive environment. They can put in their code, they can develop their analysis and create results. So, and now we propose that there's a continuous analysis container. So basically they commit their changes, and then in this side of this continuous analysis container, the whole pipeline they developed gets rerun. So when it's developed, it's rerun via some CI/CD system immediately. So we know that the results that are produced here are that they actually can be created by running the analysis again. And these results that are reproducible can be pushed to the outgoing data store then. You could also push explorative results. This would also be possible, but the kind of proposed workflow that we recommend to the scientists then is to first make a reproducible analysis and then publish these results. So now these results go out to the outgoing results store. We have some separation here, so this does not get mixed up. And then the results are brought to a data outlet review console. So the idea here is that every data that is supposed to leave the institution is manually reviewed. So we have some kind of diff. If nothing has been published before, then basically the whole outgoing data needs to be reviewed somehow manually. And if we already did that, then we can just review the changes that's happening there. So we have some high confidence. So we know that when the data is supposed to leave, it has been reviewed before, so there's no private data left. And when that review has occurred, then we publish these results in form also of a git-annex repo, and so we have that reviewable by the public, and the researchers can actually use that inside of their publications. So this is kind of the idea of our architecture, and we wanted to give you some more insights into the way we designed this reproducible execution environments, especially from the structure. And there, Philip will say some few words.
Yeah, thank you. I'm just going to quickly go back one slide and point out just right of the nice git-annex logo, there's the continuous analysis container. And the idea there is also that on the one hand, we might get new data coming in, and on the other hand, when we have this federated use case where the data processing is done in the collecting hospital itself, these two environments will be equivalent, basically. So both these use cases need to be kept in mind for the ARC-C. So the reproducible execution environment is basically the core of the data science orchestrator. And what do we want to do? Well, we want to do GitOps, kind of. We have one source of truth in the GitOps repository. We have a YAML file format that documents in detail what all the things that go into the analysis code. And also, this Git repository references the data repositories. input data, output data, as you had seen on the previous slide, are split up. We also have provisions for intermediates. This might be handy for exploratory statistical analysis and for handing off some more complicated analysis between one scientist to another. We just went with best practices and have a vendor subtree, though we are a bit torn currently between doing Git submodules there and really doing Git subtree for archival purposes, for long-term documentation of what happened when where. It's probably a good idea to really keep all the trees in the vendor subtree. And if we can create automated modules to update things as needed, that will probably be a good user experience. So what are the invariants? Most of that has been said. So we build an OCI container of that concrete environment that's going to run the calculation. We're running it as container. We might move over to virtual machines after the development phase for additional isolation. And this container shouldn't have outgoing network access, of course. We're basing everything on the Debian stable with a pre-selected static package set, and that's what that OCI image builder will add up on. And even for that base image, we want to record the exact hashes. This is just an example for our contract with our users. We had hoped to prepare a little demo for this conference, but then last weekend something happened around SSHD that kept me busy quite a bit. So this is what we are showing today. Structure is pretty clear, and we're kind of torn between existing file formats for recording the state, but for the user experience we're aiming at with the web and with different people making policy decisions and with different level of technical know-how, we felt it's really important to have that one central YAML file that records everything, and that really gives a good overview of the state, and then you can diff that. And this project, for example, would include a Python module to do the actual analysis. So still an open question for us is we will heavily restrict access to the raw data, but that doesn't mean we absolutely have to have separated git-annex branches. So if we do the access control and at the level of a git-annex get, so will we? Maybe is it a good idea to in the sense of having this whole state of the world be represented in the published project? Maybe it's a good idea to have the one git-annex branch that has tracks the incoming and the outgoing data. This is not a policy decision we're going to make ourselves. It depends on what feedback we get once we have a prototype up and running and do some sample research project with actual data scientists, especially data scientists with a medical background, not IT background. So let's see. And depending on that decision, we actually might still end up punting a lot of that work to DataLad run, but this is not, at this current moment, not decidable yet. So we wanted to give a quick outlook for the next work. So for most of the components, we have just a simple proof of concept work done this quarter and in this quarter that just started and the next one. There will be a lot of development and integration work happening. There's just recently very renewed interest from our partner at the other DZGs that said, okay, yeah, well, now the political climate has changed, so now I can afford to put a lot of my own time into that. So we're very looking forward to what will happen there. And after this is done, then we're kind of planning for a phase 2 long-term of that project and really solve that federated data processing use case. So I think we've laid the groundwork for that, but the proof, as I say, is in the pudding. So let's see how it will work out once we get to measure in the real world. Yeah, thank you for your attention. I think we have a few minutes for questions. Otherwise, please feel to contact both of us. Yeah, thank you.
We do have time for direct questions from the audience, and we have 2 of them.
Hi. Thanks. That's a great talk, and it's given me a lot of ideas because I'm building kind of a similar platform, but much simpler. And I'm thinking whether this will be ready by the time we want to do. It will be 2025. So we're doing ETL work in this year, converting into Fire, for example. I don't know what format you're using, but Fire in sort of a flat format, so that. Yeah, but like I'm exporting into Parquet so that people can use DataLad or git-annex. But yeah, this looks great. So like if it's open source, when it's open source, parts of it.
Let's come into contact, I would say, so we could see where we can collaborate.
Yeah, that sounds great.
I was just wondering how far you got with the issue with the git-annex branch and potentially having multiple ones. That's something I've considered a couple of times in projects, and if you've done anything more with that. Or is it just an issue?
Sorry?
Or if it's just like an issue that you're aware of?
Yeah, we're aware of it. As we said, we're both also privately users of git-annex, so we can anticipate some things based on that experience. We looked at it, and I looked at the DataLad collections that uses Git submodules internally, and it might be a good fit if this is something that doesn't need to be tracked or reviewed a lot. So basically, having the moment we add Git submodules, we complicate our audit log, we complicate the user interfaces for reviewing the state or differences between 2 states, and we kind of want to get some experience how non-technical people react to the concept per se before making a final decision on that. So just saying, okay, everything is tracked in this central git-annex branch, and just when you do a get, you get a 403 not allowed. That might actually be the simpler way to go about it.
Okay, thank you very much for the presentation. I suggest we take the remaining questions to the panel discussion. And I would like to invite our next speaker, Kyle Mayer. Kyle will take us on a tour of Magit. Kyle is a core maintainer of Magit and has been a DataLad developer until around 2021. He currently works as a senior data science engineer for the Metrum Research Group.
Thank you for the introduction. I had the pleasure of working, contributing to DataLad for a few years, working with Jarek, Michael, Adina, Benjamin, and others. It's been great to be here to hear about all the tools and users that are Anyways, to hear about everything going on with git-annex and DataLad. It's been great. This talk is not about git-annex. It's not about DataLad. It's just about Git and really just one interface to Git. That interface is named Magit. It's built on top of Emacs. Many of you know what Emacs is. For those who don't, it's a text editor. It's old. It's odd. It takes some getting used to. In addition to being extremely customizable and arguably a wonderful editor, it's a really powerful environment for building text-based tools, and that's what Magit is. Okay, so before getting in to what Magit looks like, let me acknowledge two key people behind it. It was created in 2008 by Marius Vollmer. Since then, over 300 people have contributed at least one commit to the repo. But Jonas Bernoulli, in particular, has put in an enormous amount of work making Magit what it is today. And of course, commit counts are just capturing a very small slice of the amount of work he does maintaining Magit. And not to mention lots of other Emacs packages. Okay, so Magit. So this is not Magit. This is Emacs. Let me first orient you to sort of the layout here. So we have just this kind of big window here. That's Emacs. This window down here in the right, that's just going to be kind of logging my key presses. Not too important to pay attention to, but maybe a helpful reference. I then also will occasionally just pop to this regular terminal. Hopefully that's legible enough to run some Git commands for comparison. Okay, so the entry point for Magit is typically Magit status. By default, that's bound to Control X, G. So that will pop up a status buffer. This shows you a lot of stuff you'd expect to see with Git status. It tells you what the current branch is, what the upstream is, nearest tag, gives you a list of some of the most recent commits. There's a section indicator here. What that's saying is that it's a collapsible section with content, so I can do things like hit tab and display it. So anyways, this is just an overview buffer, and then a key concept with Magit is that nearly everything at point is actionable. So I'm hitting N to kind of move down different sections. If I get to a commit I want to show, I hit return on it. I'm popped to a buffer showing information about the commit. And let's say then I can kind of navigate the commit. I can visit the blob for a file by pressing enter. Again, everything at point is actionable. I could jump to the file in the working tree with Control J. So that's the revision buffer. Then you also want to typically invoke commands directly, of course. So Magit exposes those through menus referred to as transients. So let's say I want to create a log. I'll hit L to pull up the log transient. You'll see at the top here, there's just various git log options that should look fairly familiar. Down at the bottom, there's a set of actions. These are just different variants of the command. So log the current branch, log local branches. Other's an interesting one because that one's just give me a revision range like you would git log on the command line. So it's flexible. You can pretty much get it to do most invocations of git log. So let's say I want to look at, well, actually, before saying that, let's say I wonder about what one of these commands do, what's related. I can hit question mark, I can hit U, and I'm popped to a buffer saying, okay, this is what the underlying command does. So once you're done reading that and you're happy with that, you can hit Q and it pops you back to the transient. If you're like, I don't remember what some of these switches do, I need more information in terms of the git log options, you can question mark, and you're popped into a man page for git log. Again, once you're done with that, hit Q and you're back to the transient. So, okay, I want to log commits by Adina. She's all I care about in this project. I hit enter, and then I can get, for to see the current log, I press L. And then I pop to what looks, pretty standard git log graph, one line. I can move up and down, same keys. I could visit the commit by pressing enter, but in the log, it's usually better to press space. I display it, and the nice thing is then that revision buffer will just track what's in the log buffer. So this is a nice view presentation-wise because it gives you the kind of high-level overview of a one log, but then you can jump into the details very easily. If you're on a commit like this one that spans way too much, you can just hit space and keep scrolling. Of course, just like before, I could pop over here to the file and visit the blob and whatnot. So, kind of taking a step back then, this is just trying to give an idea of what commands Magit covers. So shaded in magenta, those are things that have a transient, like the menu I just showed you for log. The things in gray are things that they're supported, but they don't, not necessarily through a transient. So git status is of course supported, but through the status buffer. And then the things, let's see if I can find my point, like grep, and range diff that are boxed but not colored in. So git grep is very much supported in the sense that there's lots of ways to do it in Emacs, but Magit just doesn't provide another interface for that. And then range diff, for historical reasons, it's supported but through a Magit extension. And then that leaves the ones that aren't colored in. A lot of those just aren't particularly interesting to support because they're not used enough. The only one really notable is probably scalar. That's actually, it's not a git subcommand. It's a relatively recent top-level command. Its tagline is something like a tool for managing large Git repositories, which sounds interesting and relevant to this crowd. I've never used it, so I can't say much about it. Maybe Magit, or probably more likely an extension, should support it at some point, but yeah, who knows. But yeah, so that's probably the most interesting that it's not supported. Okay, so that's a lot of commands. How do you know what's available? Do you need to remember keys for all of those commands? So if I'm back in the status buffer, if I hit question mark, I'm thrown into a dispatch that gives me all of those commands. It tells me what my keys are. So if you're just getting started, or if there's some command you don't use that much, you don't remember the key, this transient is a good entry point for it. So you'll see a lot of things you use every day there: branch, diff, fetch. So like say I wanted to run diff, then I can just hit D, and I'm thrown into that transient. Looks a lot like the log transient we just saw. Okay, so everything I've done at this point has been inspecting, so let me start to modify. I'll check out a branch by B, and then I'll hit, so that's the branch transient, C to get to the new branch, and then, yeah, let's just call it topic one. Oops, I don't remember now how to use this. Name, and then I'll call it topic one, and then we are now on another branch. And so let me start to make some changes so I can do something with them. So let's say I'm in this file. Let's see, I'll add some noise at the top, just white space. Let me search for this comment by Michael. He claims he wasn't confident. That seems unlike him, so I will change that to now. Can get rid of that. And yeah, let's see, let's also fix up that indentation. Okay, so that's one file changes. And here, let's just add some more exclamation marks. Okay, so now we have changes. So if we wanted to stage everything, capital S, just stages everything. Can unstage with capital U. If we want to do it more piecemeal, I can move to the file, and as I said, S was for staging. If you're on the file and you just press S, then you're going to stage that file. Now, If I go down here, it'll be in the stage section. I can commit with a C. This gives you options for committing, but default's fine here. Commit with C, you're thrown into a commit buffer. And then, yeah, you can do a body if it makes sense, and exit with Control-C, Control-C. And so now I have that recent commits section is replaced by commits that aren't yet in main. So this just kind of is tracking your series. Let me really quick, I'll stash these, and I'll check out main, and I'll make one more commit so that you see what it looks like when main has a commit that's not in. So I'm just making an empty commit. I'll pop back to topic, and so now you get this section that says unpooled from main. So yeah, just it tracks what's in your upstream that's not in yours. So again, it's basically what you'd see if you run a git status, right? But just kind of laid out with all the commits. Okay. Let me pop that stash. Okay, we're back here. So if I want to then stage hunks within a file, how do I do that? From the command line, you do something like what? Git add p, say, no, I don't want that, no. Yeah, I want this, but I want something in it, so you S to split. Okay, this is what I want, I don't want anything else, Q. Is pretty much how you would do it from the command line. And then, so let me undo it. So now we have that stage, but let me undo that. And so from a git, how you would do it is you'd go to the line you want to stage, you hit Control space to start defining the region, move a bit to define, so you just highlight what you want to stage, you hit S, and now you've staged it. So arguably a bit more streamlined than what you would do with git add -p. So then I can commit that CC again. I'll commit that. Okay, and then, so now I have another commit. Oh, I just realized I made a typo. If you make a typo in the tip commit, Control-C, then there's this reword variant and just pop you right back to the buffer, fix it, and then Control-C. So that's for if you have a tip commit, an easy way to just kind of reword it. All right, let me commit the rest of this. Let me say I don't want these changes, so I'll hit K to discard them, and then I'll commit the rest of these. Oops, not all of them. Let's see. Anyways, okay. Okay, so now I have a series, but let's say I realize that I want to reword something a bit farther back. So I showed you how you amend reword the tip commit, but if you want to go deeper back, you say we want to reword this. One way to do it, which would be kind of what you do from the command line, you can do an interactive rebase. So I can hit R, pull up the rebase transient, hit I, that's going to throw me into interactive rebase. I could pick reword and then reword the commit. So this is the to-do list you'd see from the command line if you're used to editing series like this. Let me hit Control-K to cancel that because I'll show you a quicker way to do it from a git. So instead of doing that interactive rebase, I can just hit W for reword, and then it's just going to throw me right into the commit message buffer, and I can reword it as I want. Control-C, Control-C to get out of it. So it streamlines it a bit, right? I don't need to deal with that to-do list. I can, if I need to, I can do a standard rebase, but I don't have to. Okay, and let's see. So the other thing is if you're working on a series, a lot of times you'll make a cleanup commit, and that should have actually been in the previous commit. So from the command line, let's see where, let's get a view of where we are. Oops, not my password, please. I can't type when I'm doing demos. Okay, so this is our series, and so say I change this file, I add some exclamation marks to it, I can run. Okay, so now if I wanted to fix up, then from the command line, I'd do something like, let me just search for it so I don't get it wrong. I could do something like this. This would, add the file I just changed, and it says, I want to fix up to this third commit here. Now if we look at the log, it's got kind of this special markup fix-up that will tell git rebase auto squash, okay, combine that commit and replace this first commit with the combination, a commit that's now the combination. And then, yeah, I can do an auto squash and pops me into the editor, and then there I am. From the, okay, so that's it from the command line. You could do the same thing from Magit, but it's a little, you can also use a more streamlined variant for, that's called instant fix-up. So let's say I want to make some more changes. So I want to align this, and then, okay, actually I don't want this white space changed, so let me discard that. Okay, so now I have more changes. Again, I could do what I just showed from the terminal. I do Control-C, and if I pressed F, it would prompt me for a commit, and then I'd make that special fix-up commit that would then be squashed down. But I can just do it instantly. So if I press F, capital F, that's instant fix-up, pops me into a buffer, says what commit do you want to like absorb this into. I pick the commit, and that's done. So there's no extra rebase, or there's no extra commit and then an extra rebase step. It's just, yeah, what commit do you want to bring it into? All right, how am I with time? I forgot when I started. Oh, okay, there you go. All right, so I will show one more kind of streamlined variant. So say you have this current state. I have this D commit and topic, and I don't really want it there. I decided I actually want it on its own branch on top of main. So basically, I want this state. So the way I would do this from the command line, I would check out topic 2, I'd cherry pick D, then I'd check out topic 1, then I'd rebase topic 1 to remove D, and then I get what I want. So there's some variants in Magit that kind of do this for you. So let's say, okay, so say to kind of map that cartoon onto this, say I want to get rid of the more confident commit. I want that on its own topic 2 on top of main. So I hit A, capital A, to pull up the cherry pick menu. There's an apply elsewhere. There's spin out and spin off that kind of do what the situation I'm describing. The difference is that spin off will check out the new branch, spin out won't. So we want the spin off or spin out one. I'll press N. Or actually, let me move to the commit I want to actually extract. Yeah, so capital A, I press N, and then I say, okay, yeah, this is the commit I want. Where do you want to put it? I want to put it on top of main, call that topic 2, and then it does it for you, right? There's topic 2. More confident is no longer in topic 1. And if we look at what Magit ran underneath, then we can pull up a status buffer, and we see that it pretty much does the sequence of commands I outlined. So it just, yeah, makes a new branch and does all of that for you. So just one example of how Magit can streamline things. Right, so to recap, Magit is all about working on actionable output that's in the buffer before, like in front of you. You can drive Git commands with short key sequences, even commands that are pretty tailored and relatively complicated. It provides you with a discoverable interface for all of this. You don't need to remember what all those keys are. Provides good coverage of Git commands. But it's not just a mapping between the command line and Magit. It provides new functionality and workflows. Right. So as a closing thought, you may be thinking, well, that's all. Some of that's cool, but I'm never going to use Emacs. I like my editor perfectly fine, thank you. And that's fine. I should mention that there are quite a few Magit-inspired tools. Magit even has a wiki that lists some of them, so perhaps there's one that's a good fit for your workflow and at least does some of this. And more generally, it might be useful to look at how Git does things, in particular how it manages to map a very complicated Git interface onto a set of interactive commands. And even if you're not in Emacs, maybe that provides some ideas for the next interface that you create. So that's it. Thank you.
Thank you very much, Kyle. I think we can segue directly into the panel discussion. So I'll invite Philip and Markus Katarina back on stage. And I'll start with the first question to Kyle. Or maybe first to the audience. Who of you knows that if you git push, you can git push with force? Who knew that you can also do git push force with lease? Okay, quite a few, but less. I must say I learned that from Magit. So you didn't show us the push interface, but in there, you have both options listed. And I think that's one thing that I like about it is that it doesn't try to, in my view, it doesn't try to hide the complexity of Git. To the contrary, it puts this complexity at your fingertips. So to the question, was this a conscious design decision, or was it something that kind of happened because the transient menu was what the developers had to work with?
Yeah, so I think that's a very good point, and I think a lot of people say that using Git teaches them more about Git. It certainly wasn't my decision, so perhaps I can't say what the intent of other, Jonas and even the original creator, Marius, what their intent was, but I think that probably was, yes, very much to provide an interface that exposes the complexity and maybe makes some things more streamlined when you want it to be, but in general does not hide it. So yeah, I think that is a very good point, and I would say, yeah, that's very much a design goal, at least at this point, to keep it that way.
All right, and now to the audience, questions to all our panelists. I think Joey can start.
So Kyle, are you familiar with git-annex? I know it exists, and I know nothing else.
I am. I wrote that in 2014.
So, I didn't know that.
20 minutes. But yeah, so I did. I wrote it. I still use it probably every day. It certainly could use more love, more time. I'm interested if anyone wants to contribute.
I was wondering if it did anything along the same lines of making things discoverable, the same kind of.
Yeah, there's the transient menu so Jonas created that library, and lots of packages use it now, not just Magit and Magit extensions. And so it uses the same transient. The amount of actions are limited, but a lot of the file actions you'd expect, so unlock a file, get files, all of that's exposed through a transient, sync. So basically things that I used and wanted. You can, of course, add files directly with git-annex add with similar to how you press S in that buffer. You can press, I think it's @ sign. I was struggling to come up with the name. Anyways, yeah. So but it doesn't offer much else. It's like there's an unused log and maybe and list. There's an interface for parsing the git-annex list output. But yeah.
Hey, I have a question about this secure health data processing, because it exposes this very interesting conflict between decentralized and centralized management for me. And I'm thinking about it at a bigger level. How much integration is there from the community, or is there an evolving community that kind of tries to tackle this problem together? Because it seems a very fundamental one. And I can see an option that every institution goes it their own way, but I can also see that it becomes centralized. And maybe I just misremember things, but I also believe I heard that there is like standards evolving from the European Union or something, for example, that actually characterize what a system needs to fulfill. And you guys also mentioned a bit that there are feedback processes. Could you explain that a bit more? Like, how does that look like in practice? How integrated is this? Also across institutions, and how much regulation is there at the moment that actually specifies how systems should look like?
Yeah, this kind of, so our approach comes from the time before this was kind of this political topic. So we had some goal that we're now trying to fulfill, and we are we did not look too much into this into the compatibility with the European health data space, basically, but there might be some applications there. But it's a good point. Yeah, I'm not really sure.
Okay, so the European Health Data Initiative, which basically says, okay, we want to have a central actor. Sorry, missing a central file for every patient, and things like this have been discussed in German healthcare for at least 25 years. And there's always been a very strong push against this. But now that it's coming via the European level, there's a lot of political will, might have something to do with the current health minister in Germany, to lead in that process and get the health data of German patients into mineable format very quickly, and not, in my opinion, this is not a process that's very well thought out. So the reason why we get a lot of good feedback right now for our approach is because it comes from the point of view of decentralization and of taking care of patient data first, and so we might be already too late to establish it in a broader context, or we might be just at the tip of this discussion, which is going to become a broader societal discussion. We have no idea right now. We're trying to get the technical thing off the ground, and then we'll see what happens. But your question about feedback was more about the feedback process in the...
No, I think that clarified things. I was wondering how much regulation there is actually about the infrastructure part, right? Like, I know that some people probably are also lobbying for certain solutions more so than others, right? So I was really wondering about what the landscape looks like, whether it is a centralized attempt or like a special interest group attempt that's also trying to convey what the technological possibilities are, because some of these are, innovative tools, and I wonder whether those are already in consideration also by lawmakers and policymakers ultimately.
I don't think I can really answer the question. Yeah. So I come from a medical family myself, so I've been following the discussion, and I haven't seen a whole lot of discussion about decentralized approaches here. So it's more like, okay, if we give the patient case files to the health insurance companies or public companies, it's in Germany often, if they're by law demanded to control these and regulate this, how secure is it going to be? And I haven't seen a whole lot of discussion. Do we really need that, or can we get away with making health data more interoperable by going to standards like FHIR? So that's FHIR for those not familiar.
making it so different physicians can search data better that other physicians have collected. We're aware of that approach and have been discussing it for quite a while. But right now, the push that I see publicly is to go in a very centralized direction.
Thanks. Yeah, so what I wanted to also make clear, like why I'm so unsure to answer this is like this is such a broad, like medical data. It's like there's so many categories of medical data. It's like so a lot of the discussion is about routine data. That's kind of that's the data that's captured when patients are treated, but there's a lot of other data. For example, data that's created when the people are in studies. Then there's there's a whole lot of categories, and I would like to be careful to generalize here, because I think it will be so from my experience, this data is handled in a very diverse manner right now. So I'm not sure if there's this one solution coming right now. I don't see it in Germany, at least.
I would like to come back to your suggestion of operating on different git-annex branches, or like separating annexes or whatever. I think I didn't quite understand what you think you would gain from that. Can you elaborate on that?
Yeah, actually I thought again, while I was listening to your talk, I thought about this question some more. And I think for me it comes down to a separation of concerns point of view. So it might be a bit cleaner if you say, okay, this data set with the metadata that's describing it, which we know in git-annex is not necessarily personal data. Yeah, so it's just the hash, which we hope is non-revertible, and the cryptographers tell us it isn't revertible. Tracking this in separate git-annex subtrees, in my mind, makes it easier to reason about, but it also gives up this GitOps principle of we have this one repository that has all the knowledge. And git-annex does something very interesting, that it can tell us, okay, this and this machine or environment has made a copy of this specific file. And we're not sure in how much detail we'll be able to do this. But yeah, if we have the separated environment that calculates a statistical analysis, and the output of that is reviewed very carefully, we might still be able to merge information of changes that happened on the git-annex branch back into the main repository. Yeah? But then we need to be careful that this is really only git-annex metadata and not a data path that can leak data by some scientist who's not well-meaning. Yeah.
So the concern really is about what may end up in annex metadata and therefore in the annex branch?
Yeah, for me, I think it's well controllable what will end up in the metadata, but it might be easier to reason for non-technical people if we separate the whole worlds. You know? In my mind, it's going to be a better experience if we have that one git-annex repository and that one git-annex branch, and it will ease our development of software on top that allows for the reviews, etc.
Okay, thanks.
The next question is yours. We'll make him sweat here. Question to Kyle. So I use my Git only pretty much when I need to stage chunks, right? Because what you showed is so convenient. What should be my next feature which triggers me to load that Emacs operating system?
Yeah, I would say the instant fix-up variants that I showed are pretty, like I use the command line a decent amount for Git operations too. You know, I'm in a server and stuff. And the thing that I feel the most is probably, yeah, the staging you mentioned. That's a big one. And then the fix-up variants to really just quickly, you know, kind of polish the series with additional changes. That's probably, yeah, I'm trying to think. I mean, there's a lot I didn't show, of course, and of course someone would mention, I was like, oh yeah, that too, and that too. But I would say that the kind of series refinement commands are probably way up there for me.
Yeah, and while you were presenting, I shared on the chat Junior's interview, right? Interview of Junior, who is maintainer of Git, and pretty much what struck me most in that interview is that what he thought is the greatest thing of Git is that with that, this distributed work, you could make regular programmers to look like a great programmer. When you don't rush committing and pushing, right, but you take care about going through the history.
I tried to work this into the talk, but I couldn't make it work. It says more about me, but Joey has this really old post, like a while ago. He probably doesn't even remember. It's like called like Our Beautiful Fake Histories. And I just, for some reason, just like, you know, took up space in my brain, and I always remember it. And I think, and like his point with that is like, he's basically like just saying, look at all these options that like Git commit has for refining, and like I think it actually is more about Git bisect or something. But anyways, just that kind of came in my head, and like maybe Joey's history is, I've had to go through it a lot when working on DataLad. It's very nice with very informative commit messages. He might be able to do that first pass. There is no way I am ever doing that first pass. I need to refine series. So yes, that's why the commit refine, like exactly what you said in terms of making, yes, someone that cares enough look like a really good programmer. That's what it can do.
About the platform, you said that how do you guarantee that those environments are reproducible, right? You mentioned they've been reproducible builds, but then there was this Merkle tree, and that was the answer, right? So could you give a little bit more details? Like, do you generate containers? Do you ensure that they're reproducible by using snapshot repository of Debian, or what's the juice, secret juice there?
Yeah, so of course this is somewhat aspirational, the reproducibility, and will have to be measured against the real world. So what kind of algorithms data scientists come up with, and often data scientists that are not really that deeply into IT engineering, I would say. Yeah. So what we want to do is create an environment where it's trivial and where you have a short feedback loop. If you leave the path of best scientific practices, yeah. So we have the interactive environment because if you don't know what you're doing with some data, you want some kind of REPL, yeah. And Marcus has told about the in my opinion, pretty ingenious way he came up with that we can even take out the element of copy and pasting what's shown to you in the web browser, yeah? Or that danger that exists there. And then in the interactive environment, you would develop an algorithm, and the output of that algorithm, you can see some numbers, but basically in the format that you can officially get it out and use it in your published paper and so on, would then come out of the non-interactive environment. And so if these differ, Yeah, or maybe we can run the non-interactive environment on 2 different machines. Yeah? If the outputs differ, then you know, as a data scientist, you messed up somewhere.
Yeah, so about this execution environment, I thought about some approaches there. So yeah, we have the hash from the OCI image, but I also thought about, like, you could also push the you can export an OCI image as a tree. You can also put that in git-annex. I'm not sure if this is really good, but then you could like version the whole image with.
That's exactly what we do, and there is a person even who coded it up. Yeah, there is DataLad container.
Yeah, we need to look into that. From what I remember, was that DataLad container kind of did not have the right. I could not get it to deploy in the scenario I wanted. But I wanted to look deeper into it, because I was like, this is basically, it assumes that you run the DataLad command in a machine that can run a container. But when I want to kind of provide the container from the outside and then people to work inside of it. Like, this might be some Matroshka problem here. So yeah.
We could talk more about that.
Yeah, sure. So I'm not. I thought about this. Yeah.
We have time for one more quick question.
So, quick question. I don't know whether you would hand out Annex repositories from that environment for people to use. But if you do, or if anyhow the keys show up in the output, do you deal with cross-referencing 2 files in where people only have access to the files in one context and should not know that the same file was used in another context?
Yeah, this is a really good point. Something we also considered for this outlet review is to, for example, go through all the pseudonyms and see, okay, is there anywhere is the pseudonym inside of this outlet data, and then just automatically say, okay, this must not go out, for example. Yeah, this is kind of a problem. We might when inside of the file names there is private information. This is kind of, I'm not really sure how to solve this. We could ensure it by not doing private information inside of the file names. But yeah, I thought about this too, and yeah, but not too deep. But it is a problem. And especially for the pseudonyms, we need to ensure that automatically that basically we grab through the output data, see if there's any pseudonym. If there's any pseudonym, it does not go out. Yeah.
All right, thank you very much. I suggest a round of applause for the panelists. And we have a coffee break now, and afterwards we have the last segment of today. Thank you.
I think it's time, right? So, I guess everybody will come down, but we should continue, and we have the last session of scheduled talks now, and it will work slightly differently because you see 3 people already at the stage, and it's not a panel discussion yet. So we have a segment on I think everything related to the Dataverse system, and so we have 3 people in a longer talk. So I'll introduce all of them right now simultaneously. So we have on the left Philip Durbin, and he has worked full time on the Dataverse core development team for over a decade, and is part of the Institute for Quantitative Social Science at Harvard University. And then in the middle we have Oliver Bertuch. And he's a research software engineer working on solutions for managing, publishing, and archiving research data and research software. His passion is bringing these 2 worlds together to promote open science and reproducibility. Based at the Central Library of the Research Center in Jülich, he works closely with the institute that I mentioned before at Harvard as part of the Dataverse core team. His focus there is on issues such as containerization, research software, readiness of Dataverse repositories, and as a co-PI of Hermes, he is developing a new key infrastructure element for automated metadata-rich research software publications. And in 3rd position, we have Jan Range, and he's a skilled professional holding a Master of Science degree in biotechnology. And since 2021, he's been working as a PhD student and research software engineer at the Cluster of Excellence Simulation Science at the University of Stuttgart. Jan actively contributes to the areas of data management and biocatalysis. Yes. With a strong focus on big data and promoting the reproducibility of simulation data. Jan's contributions to the scientific community include the development of the data format Enzyme ML and Easy Dataverse, a Python library that facilitates seamless interaction with Dataverse. And with that introduction, I hand it over to you.
Yeah, thank you, Michael, for the very nice introduction. Like we were saying, we sort of forgot what we had written. Maybe I should have added that I'm also a user of IkiWiki, another Joey Hess original. And I'm a Git enthusiast. I was very proud to be one of the few to raise my hand when it was asked, who's heard of Git force push with lease? I was like, yes. Although I only heard about it like 2 weeks ago. Command line junkie. I've heard of inodes. I feel like I'm in the right place, the right crowd, so I'm very happy to be here. Oh, and by the way, this is, you mentioned IQSS at Harvard. This is like the headquarters of Dataverse, this round building underneath Jan's name. So I just thought I'd give you a little picture of the other Cambridge. Cambridge is distributed just like Bristol. This is the one across the river from Boston. Okay, here's our agenda. We're going to talk about what is Dataverse in the first place. And then, because this is a distributed data conference, I thought let's talk about the way that Dataverse distributes data, especially metadata. So we'll talk about OAI PMH, which we heard a little mention of in the One Data talk from Lucas yesterday. We'll get into distributed data, Dataverse, and DataLad. There is a relationship here. And then we'll hear from Oliver and Jan on future architecture, mixed-file storage, configuration with Jülich data, and PyDataverse, use of Dataverse APIs. So, good stuff. Okay, what is Dataverse? Dataverse is open source research repository software. There are 116 installations of Dataverse around the world across 36 countries. We run it ourselves. We eat our own dog food at Harvard, Harvard Dataverse. What might be unique about Harvard Dataverse is that there is an open invitation to free data hosting for your research data, up to 1 terabyte. So if that sounds of interest to you, please get in touch or just create an account and start uploading data. Let's see, I thought I would, and then of course, Dataverse is a community. This is a picture from our annual meeting that took place last year in Braga, Portugal. Jan and I just got back from Mexico about a month ago. That was the 10th annual conference. And you're welcome to join us next year. We'll be at the University of North Carolina in the States. And then I thought I'd just give you a visual of what a data set looks like in Dataverse. So this is actually my data set. It's not a fancy, important data set by any means. It's just me trying to figure out what's going on open source-wise at Harvard, because I'm a big open source enthusiast. So down at the bottom, you see some files, a Python script, and then my tabular data, and then my primary data, which is just a bunch of JSON files that I downloaded from the GitHub API. Oh, I was just talking to Julian, who talked about zip files earlier, and there's a nice feature of Dataverse where we support the HTTP range header, where you can say, I only want the bytes from here to there, like maybe the middle of the file. And folks came along and built, some community contributors, built a tool on top of this that we call the zip previewer downloader, so that you can click on this file, then you get a graphical view of all the files inside the zip, and you can just click and say, I just want the README, or I just want this one file in the middle. So it's a nice little feature to mention. Yeah, speaking of tabular data, we have a lot of support for it in the sense of we will try to what we call ingest the data, so that, and if ingestion was successful, then you'll be able to see the number of variables, the number of observations, and you'll have access to a bunch of tools for exploration of that data. So you would click the eyeball, for example, and see a preview of the data and maybe tools to explore. This little robot thing is a new tool from my boss. It uses LangChain and OpenAI to give you a hint of what the data might be about. So it'll read in the first rows and variables and try to guess. And then you can follow, it gives you a prompt. You can follow up with further questions about what, tell me more about this data. I'm only using the bare minimum of fields, title, author, description, subject, but there's a lot of support for custom metadata blocks. So it could be any field of science. We've had structural biologists come and create their own blocks of metadata. You can make a neuroscience block if you want, as many fields as you want, drop downs of all the different vocabulary you might use. Oh, and one more thing to mention is in Dataverse, files can have files. We call them auxiliary files. So for any of these files, I could upload as many files as I want, small ones, big ones. Maybe I want to upload more metadata. Maybe I want a README per file. We also made use of this functionality recently for HDF5 files, or also netcdf files. When you upload them, we grab the header from the file and then store it as an auxiliary file. So if you don't want to download the entire HDF5 file, you could just preview and see the header. Yeah, so I think that's about it. A DOI, of course, one of the main features of Dataverse. A DOI is sort of out of the box what we expect you to use, but if you install Dataverse at your institution, you might also choose instead handles or something called permalinks, which is basically just relying on your own DNS. Yeah, dataverse.org, so you can check that out. There's a long list of features at this URL, software features. I'm going to try to talk about a few of them that I sort of highlighted, and as I said, OAI PMH will be of interest to this crowd, I think. But past embargo and restricting files, this page goes on and on. I just wanted to give you a sense of that there are lots of features. Jan and I were talking about how we do support the Open API specification, and now we can get a list of how many APIs do we even have, and the answer was 345. Yes. So that should give you an idea of how much functionality there is in Dataverse, like 345 APIs you can hit. So have fun. Okay. Because I don't have time to talk about all the features and whatnot, I thought I'd just sort of highlight a few videos on Dataverse TV, especially recent ones that go through features. So fair data, of course, data handling, how to do metadata, and intermediate curation of metadata. Here's a fun one, bringing data close to compute at Harvard Dataverse, I would recommend, and introduction to Dataverse APIs. So you can check out all those videos. Okay, distributed metadata. One of the main reasons for Dataverse to exist is to make your data discoverable, right? So we do this in a variety of ways. I'll go through some of these points. So DataCite, if you're not aware, is sort of a place where we as a repository can push information to declare, here's the title, the description, author license all this information about data sets, and people can search DataCite for data. We'll get into OAI-PMH in a second. But then I wanted to also mention, especially under machine-readable metadata, the schema.org JSON LD metadata. So we developed this talking to Google because they said we're about to launch this Google dataset search thing soon. And they explained it's pretty simple. You're just going to have a sitemap that has all of your data sets in it. We're going to crawl your site, and then we're going to look in the head of the HTML for this specific JSON file. And they explained what the format will be. As I mentioned yesterday, they're changing to this new format called croissant. So pretty soon I'll just say croissant. It's a lot less to type, but it's just a way to get the word out about your data. It's a way that if you make it easy for crawlers like Google to find and discover your data, then others can find it more easily. I think that's good. We'll move on to OAI-PMH. So one of the main points is that this is a standard protocol, right? It's not something we invented, but it's something we support, and we love standards. This means that we can harvest from any service that is using this protocol as well. They can harvest from us. So I just think in the context of a distributed data meeting like this is a great thing to know about, that I don't know if this is a big part of your world or not. Again, we heard that OneData supports this as well, which is great. But maybe there's neuroscience data that people would be interested in, that, oh, we'd like this to be part of Harvard Dataverse. If there was a system out there that supported OAI-PMH, then we could certainly harvest that. This is the details of how it works. You're basically listing identifiers, listing formats, pulling records, that sort of thing. You're advertising sets of data. Yeah. This is a complete fiction of, of who's harvesting from who, but just to give you the idea, I think we'll see in a second, it's either 29 or 39 clients for Harvard Dataverse. So we are harvesting metadata from all over the world all the time. But just to give the idea that you can harvest the data that's interesting to you. You can say, oh, you can look at what sets they offer. Oh, this set is the same research that I'm interested in. You can pull all of that in. Right, so there are two sides to this, the clients and the server. I guess it's 29 clients. And so you can see that we are harvesting, this is Harvard Dataverse, we're harvesting over 82,000 data sets. So this is just the metadata. This is just for discoverability. So people can come to Harvard Dataverse and search for data. They can find data that's not just locally hosted by Harvard Dataverse, but data sets all over the world. Yeah, our friends in Canada, that's the Borealis data.ca, so 19,000 data sets just from them. And as I mentioned, there are various formats. So the most basic format for OAI-PMH is Dublin Core. This is a very simple format that just gives you the title, the creator, the author, description, that kind of thing. And then there are much richer formats, DDI, DataCite formats. If you're harvesting from Dataverse to Dataverse, you want to choose this Dataverse JSON format because then you get all the metadata. Even if you created your own metadata blocks, as long as they have the same blocks installed on their side, then you can get all that rich metadata across. Harvesting sets. Yeah, so you can just harvest everything, but sometimes you want to slice and dice your data and offer different sets, different combinations of data. One thing we've had people ask us at Harvard Dataverse is, well, a lot of my researchers have data they've deposited with you. Can you create a set of just the professors at the University of Virginia, say? And we say, yes, of course. So we'll create a set just for them. That way, from there, they also run Dataverse. So from their installation, they have all the data from their PIs locally, and also the harvested data from us. And then this just gives you a sense of how it might look. I typed the word distributed to see what would pop up in Harvard Dataverse, and about 6,000 or so results, and almost, or about, I guess, yeah, half of that or so is harvested metadata. So it just really increases the reach of your data to have it be harvested across various systems like this. And then just a note that it is a mature protocol. It was last revised in 2002. You might be wondering, given the age, is there anything newer? There is something newer called resource sync, but we haven't looked into it very deeply. We've been pretty happy with OAI-PMH, and our community seems to be happy. So, why switch if we're happy with what we have? Okay, now I'd like to get into distributed data. How am I doing on time?
You've been busy for 15 minutes.
15 minutes. Okay, I'll try to buzz through this stuff then. Yeah, so I guess originally we just had a simple way to store files just on a file system. Very popular these days is using S3. So it doesn't have to be Amazon S3. It can be any compatible S3. And then we're starting to see usage of sort of remote files, where like maybe in the past we've always considered ourselves an archive, where we're taking care of the data and calculating checksums, and we are keeping the data for decades, right? But now we have a new idea that, okay, it's fine to have the file somewhere else, especially if it's large or if it's sensitive, and that's this trusted remote storage. And we're also exploring the use of Globus, if you've heard of that, for file transfer. I'll just say there have been some interesting stories over the years. This is a group at Harvard, structural biologists, and they had they do have data replicated around the world in the US, Sweden, Uruguay, and China. Now, they're not using Dataverse, but these are the kind of people that will come to us and say, this is what we're doing now, and we want Dataverse to do this for us. Like, if we move to Dataverse, we still want this, we still need this. And so this is sort of like a challenge to us to get this working. It's part of why I'm here. And then another story is just installation. They're not on the map yet. They're in Asia, and they're basically have a very generous offer that they could mirror data from Harvard Dataverse, and maybe we could do the same, just for like CDN type purposes, just to have the data much closer to the people downloading it. So it's another challenge. We're still thinking of how we might do this. I don't know a lot about all the AWS services, but my understanding is that you might be able to use something like CloudFront to have people download data much closer to themselves. We may or may not stay on S3, so I'm not sure if this will be an option for us. Someone gave a talk from Storj at a recent one of our meetings, and I guess this is out of the box how it works with them. They're compatible with us because they're compatible with S3, but in this case, they distribute data around the world, so this could be a solution for CDN. I don't know. And then finally, I want to get to Dataverse and DataLad. So Jarek has been hanging out in the Dataverse chat rooms for a while. I think over 10 years. I looked, it was March 2014, so appreciate that we've been talking so long. We finally got together at FOSDEM in 2020 and said, let's integrate. And Benjamin is the one who wrote this code, this link on the left, this extension. So from what I understand, you can add in this extension to DataLad and push data to Dataverse. We'll give you a DOI. And yeah, I'm happy to hack on this during the hackathon tomorrow. Okay. Next is Oliver. Thanks.
Okay, in order to stay on time, I'll start at stopwatch. As Michael already introduced me, I'm working at a central library, and we're having our own installation of Dataverse, which is called Jülich Data. Jülich is, or the FDJ is always very creative when it comes to names of services. It's always something like you or Jülich or whatever. So why would we be different? And what is Jülich Data now? So this is what the header would look like if you go to data.fz-jülich.de. And we started in 2020 with this installation. And what we wanted at the time is, okay, we need a data registry. I'll come back to what that means in a bit on the next slide. But first, the show running is happening, we are the showrunners at the central library. So we are using resources from our IT department, but we are not like a scientific institute or something, but we are like people from a library who know a thing or two about metadata. And we have an open science team, and we are obviously doing this for the whole of the campus, which is about 2.5K researchers. The FDJ has about 7.5K people actually as a staff. And so far, we've tried to go with a zero storage policy. or more, let's say an ideal. So the publication personas we were currently targeting is Alice and Bobby, because Devin, well, sorry, but I can't help you. And Alice is rather common, actually. So we heard a lot about people using Gin and neuroscientists pushing stuff to Gin and stuff like that, or to eBrains. And so I understood that there are people out there who are required by funding agencies to push something into eBrains, but we also need kind of the information, okay, there is something out there, because we need to report to the Helmholtz Association, which the SRJ is a part of, to receive money from them. So we need to report, okay, here's these many data publications, they are associated to these institutes of ours, and they are associated to these research topics within Helmholtz. And so we somehow have to get these numbers, and usually the external data repositories do not track such institutional metadata. So there's really no way around than having some kind of registry and making people enter this information. The other use case is Bobby, which is about doing a metadata-only publication in Jülich data. We do have a lot of people that have especially large data. For example, in the JSC, there's a service called datapub, datapub.fz-jülich.de, and they are hosting a few hundred gigabytes of data. And as we are having a no storage policy so far, there was no place for this. But they also wanted to have a DOI for this to make it fair and citable and all the stuff that's usually associated with that. And so we said, okay, let's create a metadata publication in Jülich data and just have a pointer to the actual storage location. This might be a good idea for a lot of things, like if you cannot share the data because of privacy, size, or policy reasons, whatever the policy might be. All right, so lessons learned from this is, well, we started in 2020, and right now we have 150 published data sets in Jülich data. That doesn't sound right. That's not the truth. Something is clearly wrong here. So we learned definitely that the obstacle of having to register the metadata twice, once at your, like, the location where you're supposed to do it because you get money from this, and in addition, like from some kind of third-party funder, and in addition in Jülich data to get money basically from Helmholtz, well, that makes people very unhappy, and they are kind of reluctant to do that. And so far, it seems like it still works for them. Everybody's still happy, no one gets any budget cuts, obviously, but maybe we should change that. What we did achieve in the meantime is that we are well established as addressees for RDM questions. So people come to us and say, hey, where can I do this? Where can I do that? But unfortunately, there are questions about storage, and we usually have to turn people away, like, okay, so please take a look. Does your community have some kind of large publication thingy or any other solution? Maybe Zenodo is your thing, I don't know. And then come back and register. So, not really a good thing, because that very often leads to this situation where people say, this is so complicated, I don't have an easy solution. So they either go for, okay, let's build our own, or I don't care, I don't have time for this, thank you, goodbye. And the next thing, when you look at data sets in Jülich data that are metadata-only publications, is they look rather empty and deserted. So you don't really know, like, what's going on here? Is this a real thing or some scam or whatever? And that is mostly because these metadata-only publications don't allow you discovery of what does the data set look like, what kind of files are in there. You have more or less zero discoverability. And that is also not a good look. And last but not least, the SRJ joined SF-DORA, which is the San Francisco Declaration of Research Assessment in 2023. And so we do also need to look into how can we make software publications happen. Because Dataverse is currently kind of limited to or focused on data publications. And obviously that would need some work as well. 6 minutes. I'll try to hurry, okay? So we have enough time. Okay. So when we started with this, someone had a talk yesterday, I'm not sure who it was, who talked about that infrastructure needs governance, needs policy, needs to have good upfront design and decisions, because usually when you're designing the infrastructure, you're doing it in a way for the purpose you're trying to solve. And obviously, the purpose might have shifted now a little bit, because we don't need just to support Alice and Bobby. We might need to have the option to give people storage. And our infrastructure is currently not capable of handling that. So we definitely need to look into creating a new platform for this. We have been running on Kubernetes ever since we started to build the service, but we should reduce this a little bit, because we will need more computing resources when we are starting to ingest actual data and not just metadata. We also did a lot of contributions, which is why I'm on the core team, to Dataverse itself, and so we want to migrate to our upstream contributed containers, and we want to contribute a Kubernetes operator for the management. And if we're talking storage, how much storage are we actually talking? What kind of storage do we need? A terabyte, 10 terabytes, 1 petabyte, 100 petabyte? I don't know. We heard yesterday from my colleague Julia Tönnissen, there might be a need for larger storage, but do we want a copy of this, or is there some other clever way to do this? So let's do a lot of structured interviews with people around the campus to learn about people's needs. So we can start to build a solution that fits actual needs and not just some technical playground. Yeah, I do hope to be finished with the infrastructure updates by autumn 2024, but there is more, because we do need features. Feature updates. First of all, challenges regarding the support of Alice, who wants to do just registrations. Sounds easy, but currently Dataverse has the focus on being an archive, as you already mentioned. And we do have that option now to also ingest remote files. But that's nice. Very, very nice to have a nicer representation of you publish somewhere or what you publish somewhere else, but that does not solve this, the problem of how do I get the metadata of the external publication in here. You already heard about harvesting, but that has its limitations. If you're fine harvesting all of the Zenodo, great. But maybe you don't want to add the institutional metadata to all of the Zenodo, just to a few tiny bits of the Zenodo, or eBrains, or one of the other 1,000 community repositories that might be out there. And maybe they don't even provide an OIH PMH thing. So what do I do here? So this definitely requires us to change how Dataverse works. We need something that does allow harvesting of metadata, but still allows us to edit this metadata. Because we might, for example, have different requirements. Maybe it's not enough for us to say, my name is Bertuch, O. Maybe we want Bertuch, Oliver. And maybe we also require people to have an ORCID. And maybe the external data source, for us it would be a source, doesn't have an ORCID because they don't track this kind of stuff. So what to do here? So there's a lot of challenges here that might be also something that some kind of large language model with a retrieval augmented generation might help with, because we do have other sources for this kind of metadata. We do have already a lot of knowledge about the people working for us, so we could identify these people, identify which institutions they work on, what topics they work, so we could make educated guesses and suggestions to people. And we could also crawl all of the Zenodo and say, oh, this looks like someone's from Jülich. Maybe send this person an email, hey, I found this, I've enriched it like that. Would you like to add this to Jülich data? Because that's ultimately what people want, right? They would just want to click on, yes, thank you, I'm done. So we'll see about that. This metadata ML thing, this won't happen in 2024. But what we definitely need is the technical support in Dataverse to allow some harvested metadata set that is still enrichable with other metadata. And we will need something like the version PID, so that a version can have a persistent identifier, as well as other types of things like software, and not just data sets. Oh, I need to speed up a lot more. Challenges to support Bobby. Oops, sorry. So Bobby, basically, this is something, I've talked about metadata only, but maybe we should rephrase that to mostly metadata. Because, for example, Julia might have the idea here to create a publication in Jülich Data that does have pointers to these large, crazy 10 gigabyte per TIFF file things, but maybe she also wants to store some previews in there, which are way smaller, which you could like scroll around and take a look at. So you would get an idea of how would that 10 gigabyte TIFF file look like when you actually would download it, and still have, well, it's more about discoverability. You learn how these files look like and if this data set might be interesting for you. I'll skip the rest of this slide for the sake of time. And simply go to, like, we obviously have now Charlie as well. We need to enable people to upload especially large data, everything that is beyond 300 gigabytes. And here really the crucial aspect is it's not so much about like having more racks full of hard disks. That is not the problem. We have people to do that. We can throw money at this problem. The real problem is the social aspects, because free space will always be used and good metadata is hard work. So we need also to do a lot more training, especially for embedded data stewards in the institutes, because we need their institutional knowledge to judge on what to keep and what not to keep. And we definitely will apply quotas so that people do not come to us and say, yeah, sure, I did like 100 terabytes in the last 3 years of my PhD. I'm leaving tomorrow, so thank you and goodbye. Thanks for all the fish and whatever you do with this. Because that is just going to end up in a landfill. That's no use. We need a better way of doing things. Yeah, a lot of other stuff. I'm done.
Okay, hi everyone. I have the duty to be the last one. I try to not to speed up too much, but I want to quickly touch on the more practical topic right here, because I think you're all like right now asking yourself, like, how can I use it, yeah? And I think we're all hackers, and we might be interested in how we can hack into Dataverse and make use of it, yeah? So I want to talk today about some Python libraries that we have, one of which is PyDataverse, which is kind of the main one, I would say. And also, I like to live dangerous today, and I would like to give you a live demo, yeah? So pray to the demo gods today. I prayed a lot today, and I tested it a lot. It worked, so let's see how that goes, yeah? Okay, so first of all, let's touch on PyDataverse, yeah? So obviously, as the name suggests, you know, PyDataverse is a Python library to interface with Dataverse, yeah? It was initially developed by Stefan Karsberger until 2021. And from that point on, it kind of, yeah, it collected some dust. But recently, in the last year, we've touched back on it with the PyDataverse working group, and we're currently maintaining it and extending it, yeah? So PyDataverse in a nutshell, yeah, is a one-to-one implementation of the essential Dataverse endpoints, yeah? Phil already mentioned, like, we have 345 of them. Unfortunately, we don't have the 345 at the moment, but we have the essential ones, but we will have them soon, I'm pretty sure. And the thing is, like, PyDataverse in itself, I started with it, actually. That was my first touch point with Dataverse, actually. And it's really popular among these, I want to establish this term, right, DataNauts, right here. It has 59 stars on GitHub. It's about the most popular one right there, and it's used by a whopping 72 repositories. As I've already mentioned, you know, PyDataverse touches down on the, I would say, low levels of Dataverse. It's a one-to-one implementation of each of these endpoints. And with that, you gain a maximum of control and flexibility. You can do whatever you want with that, yeah? You can combine these endpoints as you wish, and that makes it really nice to develop nice things at the end, yeah? Quite recently, we also supported async requests because, like, sometimes you just want to do a lot of stuff. You just want to harvest the heck out of a Dataverse installation, and now you can do this with these async requests, yeah? So when you're a data node, yeah? Oh, I'm trying to be fast. When you're a data node, you have all the essentials right there. You can manage your collections, which is a collection of data sets itself, files, and I think files are the most interesting thing for you today, and other administrative stuff. I don't want to go too deep on that because I just have 5 minutes left. Whew. But there's one thing with using PyDataverse, yeah, and there's a caveat on that, and that is due to it being low level to the core, you know, you need to understand the native API. And 345, that's a lot, yeah? And on top of it, you also have to understand these request bodies. I feel like a good example of that, and this is something Phil already mentioned, is a Dataverse JSON. You can see it here on the right, yeah? This is required for you to set up metadata on a data set, yeah? And the thing is, it might look like there is a lot of information, but there are a lot of technicalities in there, yeah? The thing is that it's just like reporting on two fields right here. That's the title, and that's the author name. It's necessary technically, but as a user, as a researcher, if I'm first encountering that, I'm like, okay, I need to know all the other stuff, but I'm just interested in those key value relations. Due to that, we are also working on high-level APIs that use PyDataverse to combine things into much more, yeah, how can I put it, like in a single concept, yeah. One of which is dynamic metadata objects, which I will touch on, and the other one is like data file uploads to S3. So the first one, dynamic metadata objects, is something that, yeah, tries to solve this problem with the Dataverse JSON right here. Yeah, as the right-hand side illustration indicates, you know, it's taking these metadata schemes, it bundles it into Python classes and serves it to you as objects, specifically pedantic objects. It stores all these technicalities, like the thing you saw in this example beforehand, in these attributes, and takes away all the other stuff. So you can really focus on setting key value pairs right here. And we call this kind of a high-level recipe because it combines multiple endpoints into a simple interface that promotes user-friendliness and convenience at the end. Yeah. Another high-level concept that we have, and you can see this nice GIF here at the right hand, is the parallelized upload to S3. The upload to S3 is something I would say is a bit more complex than other concepts at Dataverse because it involves a multitude of endpoints and managing those. We packaged all of this together in the Python and Java DV uploader, so you don't have to take care about this. Yeah, you just pass in the files you want to do an upload for, and you're done. Yeah. And this, again, is also a high-level recipe would be built into this high-level API. It is meant for user-friendliness and usability. We want to make it as easy as possible, yeah? And now we're getting to the dangerous part, yeah? I hope it's not as dangerous as I think. We now want to have a practical example on how we can create a data set on Demo Dataverse and how we can then also update that. For this, I have a Google Colab notebook. I hope these things will, I'm being fast. When these slides are shared, you have access to that one. You can try it on your own and play around with it. So I hope you're fine with that. Okay, so let's switch to Google Colab. And I would go to the safe version because I prepared that actually. So let's just quickly run down this code on how to do that and how simple it can be. So first of all, you connect to a Dataverse installation right here. Yeah? So you have the server URL, you have the API token and everything, and you establish a connection right here. Right at this point, all these metadata schemes are parsed and are already served as these objects. Yeah? So then you can move forward, yeah, and create a data set. And I will just skip this one right here. I think this is a detail that takes time. You can just create a blank data set, and now you have all these metadata blocks and these objects now at hand. And I can now say, okay, let's set the title to my data set, add some subjects right here, maybe also add an author and a data set description and all the necessary stuff. You see, it's simple. You cannot see anything of the complexity of the Dataverse JSON. On the other hand, at the end, we will produce this Dataverse JSON. So you see right here, this is valid, and this will be sent in that way to Dataverse at the end. So it strips away the technicalities and presents you something simple. Yeah. There are other stuff. You can look into this if you want with the Google Colab. Another part that is really important is also to add files, yeah? And so it's as convenient as possible using this DV uploader right here. You just have the option to add a file, but also to add a complete directory right here, as you can see. And that's it. That's most of the things you need to do. Figuring out to upload it to S3 or not will be done automatically right here. And when you're done with that, yeah, you just simply call the upload function right here. This is a private repository that I have, so you may not be able to use that one, but then you can see it does a check of the dataset files. Is there something duplicate? And then it uploads everything directly to the S3 storage, and you're done, yeah? So now we can look at this dataset right here, and as Phil already showed a screenshot right here, this is the result of that, yeah? We have all the data that we have right here. We can also look at the tree. The metadata is cool. Of course, this is already the final version with the updated dataset, but who cares, it's okay. And that's it, yeah? That's how simple things can get when you work with Dataverse right here. Now, when I want to fetch a data set, I can also do this with this Dataverse instance right here. I can just load this data set with a PID right here, and then I can mess around with that, yeah? I can add new metadata, I can add new files, and then I just have to call the update function to update everything to its state, yeah? And that's actually about it of this demo. When the slides are shared, you can take your time for this Google Colab notebook. And I want to quickly advertise that we have a PyDataverse working group. If you want to join, contribute ideas and code, we're totally open to that. There's also a website, pi.gdcc.io. You find recordings, notes, and everything right there. And we're really active on Zulip, if you know that, because it's the best chat platform, I would say. And with this, I want to thank you, and I hope I wasn't too much over time, and thanks.
Thank you. I think we want to afford some time for some questions, if you have any.
We will need microphone there. Any limitations of Dataverse? Let's say S3, I know there is 5 terabyte, I think, file size limit, or 5 gigabyte or terabyte? 5 gigabyte, I think. So what other limitations? So I cannot upload probably files of that size. What other limitations of Dataverse? Like iNodes, you've heard about iNodes. Yeah. Would it be a problem? How many files in the data set? Would it slow down the server? You know, right. What do you know about?
Yes, there are limitations, obviously. Like you said, lots of files can be a problem. Lots of versions can be a problem. And we have a policy of that 1 terabyte for Harvard Dataverse, you know, the free storage, right? But in practice, we're not getting lots of huge data sets. I think we're only at 74 terabytes total. So we aren't getting lots of these 1 terabyte data sets. And I suspect people might have some trouble getting the files in place in the first place. Like Jan was showing, these new command line tools, this DV uploader, helps a lot because you just point the tool at the directory and it uploads these things. Yeah, I don't know. Other challenges, Oliver?
I'm not sure about that 5 gigabyte file size limit. It might be the chunk size.
No. S3 imposes, I think it's 5 terabyte.
Yeah, that might be.
Terabyte would, it's like,
however,
I lose track of all these gigabytes.
Yeah.
I think gigabytes.
Okay.
I'll double check, but there is a physical limit, like you cannot have a larger file on S3, so you need to chunk it or something like that.
Yeah.
That's what the git-annex does. Let's say you need to establish chunking strategy.
Yeah, but you can still go ahead and say, okay, if this really is a problem for you, we now have this I wouldn't say experimental, it's more than experimental, but growing support for remote files. On one of my slides, I had that challenge of maybe we need a specialized storage driver for a git-annex, for example, to have a deeper integration, but maybe it's also just good enough to support git-annex URLs or something. Because that would be rather easy to do to help mitigate that problem.
Just that, I was thinking, like, what are some of the largest data sets that we've seen outside of Harvard Dataverse? There was one in Arizona State University that I think is 12 terabytes, and one in KU Leuven in Belgium that's more like 18 terabytes. So people are uploading pretty sizable files.
There are more questions. Should we? So there was one by Mika in the chat. Is it possible to have collaborative data workflows with Dataverse?
Oh, absolutely. Yeah, we have a pretty robust permission system, and so it's actually called contributor in our system. So you would add someone as a contributor, and then they can upload files, edit the metadata. We also have some publishing workflows where sometimes the curator of the collection doesn't want to just hand out the ability to publish. So in that case, the publish button disappears, and you see a like a request to publish, basically. Mm-hmm. And then the curator receives the data set and either publishes it or returns it back to the author.
Mm-hmm. Thank you.
I don't maintain it enough, but I have a data set, large-ish, I don't know, a few hundred gigabytes on a Dataverse instance in the Netherlands. And it has custom access requirements. So essentially, all of the files are set to not accessible, and then people need to use the request access button. And I think the instance was on the previous version, so not the latest Dataverse version. But there was quite some difficulties building, ideally, an automated pipeline around requesting access, reviewing that, and then granting that via the API at that point. And I think I used PyDataverse. So I was just wondering if you have more recent developments and if there are existing like sample use cases to point to where people have actually done this kind of round trip of not just by pushing, clicking on buttons to grant access to perhaps the full data set as one or some files within a data set.
Right, right. So you should be able to assign the permission file down, that's called a file downloader internally, to the person who's asking for permission to one file. You could assign that permission to the person for the whole data set, which would include all the files underneath it. All the APIs, well, I'm not sure how new they are, but you're saying you were able to find APIs for doing this, and just that you were...
I was not. This was several years ago.
Okay. Well, there are APIs for that now. And the good news about APIs is that we keep talking about 345 or whatever, but we're actually rewriting the entire front end of Dataverse in React, which means that anything that wasn't possible to do via API, we have to make it possible. So pretty soon, all functionality of Dataverse will be possible via API.
Okay. Yeah, I think sorry, should I stop?
I think that is worth considering.
I just quickly want to add, yeah, you mentioned that you've used PyDataverse for that. And the thing is, like, PyDataverse just has like 37 of these endpoints implemented right there. We're currently working on a solution that you have all these endpoints right there. And I guess like that you haven't found it, I think maybe partly a reason because it wasn't in PyDataverse in itself, yeah? That might be the issue, but we're working on that, yeah.
Awesome. You will be around for the hackathon tomorrow, right?
Exactly.
And so there's more room for more. Thank you for the presentation and. We would move on to the unconference part. There have been a few. I can also do this one. There have been a few people that wanted to speak. I would suggest that we can give everyone like 2-3 minutes to just make their statements, whatever it is. You could also consider taking the time to pitch an idea for the hackathon, something in this direction. I know that Thomas is already here because he needs to go first.
Yeah.
Do I need to do something? Ah, okay, good. Huh. Okay, well. Okay, so by accident I'm working as a consultant, and by accident I have my web page open. So I of course visit that website every day. So yeah. So okay. So what is the thing I want to show? So recently I had a task. So we are developing a software for intracellular electrophysiology for a research institute, and we had the problem that our software is supposed to read all old data it ever produced, but we kind of missed some parts in reading old formats, and so we figured out, yeah, well, we need to test our new software on the old data, which was created by the old version of the software. So, well, I mean, you can just write CI tests, no big deal. But the thing is, our data is kind of compresses really well, and we actually want to store the data with the code. So, and the raw data currently is 10 gigabytes, and if you compress it, it's 500 megabytes. So it's a factor of 20, which is yeah, cool. I want to use it compressed, but and I looked into git-annex half a year ago and was yeah, okay, so there's no built-in solution for compression. I was yeah, okay, so I'm not using that now. So, but yesterday I was okay, well, let's chat with Joey and ask how that could be done. And he was yeah, you just have to implement the special remote. And I was yeah, sure. That sounds like a research project. But okay, actually, it's pretty easy. So what I did, so I checked out the git-annex repository, and I went to the documentation, and there is an example.sh a bash file which implements a special remote, and I just adapted that for doing compression. And so the first thing I did, well, I just removed the setting up the credentials because, well, for hacking I don't need that. And then I just really just changed 2 lines with, instead of copying, I'm using Z standard for compressing, and I'm really compressing hard because I'm ever only compress once and read then back. And so yeah, instead of copying, I compress, and instead of copying back, I uncompress, and that's it. That's the whole special remote. So that's a really cool thing because it's so short. Yeah, and if you then, I mean, if you do that, the next step is, okay, you have to copy your example.sh and name it something which is not yet taken up. Probably you will use compress. And then, well, you just register your remote with this command line, which is actually, I mean, it's a bit longish, but it's actually, hey, it's only 1 line. And what you can also do is, there's built-in support for then testing the whole thing. And so it's git-annex test remote. You just do that, and then your custom remote is tested with a standard test, and I ran that earlier, and all tests pass. And if you then commit your file, you can just see, okay, so in your custom remote, you can just then see, okay, well, this is really is it compressed remote, and it's, if you use file, it's, well, it says it's that standard compressed data, so you're really storing it compressed. But if you're then looking locally, it's, and if you do just a cat on the one, it's not compressed, and that's what I wanted to do. So yeah, thanks, and thank you for letting me go first.
Thank you. Ideally, you self-schedule. Self-schedule.
Okay, so yeah, thanks, Anne. There you go. Bye.
So I'm going to just talk briefly about the git-annex branch, which I'm sure everybody knows exists, and it's where it keeps track of, hang on a minute. Let me get my display up if I can. Yeah. Okay, so we know that there's this git-annex branch, and it keeps track of where all the files are right now. But since it's a Git branch, there's all these other versions of it out there that keep track of where the files were. So what can we do with this? So I have a mailbox file from 1996. I can say git-annex log, and it tells me each repository that it came into and left throughout time, which is mildly interesting, I guess. So what else can we do with this? This past fall, I implemented this thing, git-annex log total sizes GNU plot. And so it's just tracking the sizes of the repository, of all the repositories that contain all my data in this particular data set, as it were. So I have 34 terabytes of data that has grown over a few years. That's handy if you like graphs that go up and to the right. You can also give a variant where you do log -- sizes, and then it just separates it out by different repository. This is a different repository. This is my mail repository, so I have 250 gigabytes of email across 10 drives or something. Okay, that's handy. Here's another one. You can do git-annex log -- received. I'm doing an interval of 30 days to get like one readout per month, and then -- sizes, and you get basically a bandwidth, monthly bandwidth used by transferring files between any drive that has data in it. So that's kind of cool. You may notice the -- GNU plot up there. It just tells it spit out a GNU plot graph. You can also leave it off and you get CSV that you can then put into something that isn't GNU plot that looks better. And also, this looks horrible, and I don't know how to make it look better, and I'll bet that some of you might have at some point in your career actually used GNU plot and know how to make this look better, so give me a yell. Okay, thank you.
Thank you. Who's next? Remy. No slides.
Sorry?
No slides.
No slides and no computer because I couldn't be bothered. So most of us, when we use DataLad or git-annex or Git, we have to use the command line, and we know that's it's a friction point for new users. So how to ease that, and when you start helping someone and on their computer and they open a terminal, to your horror, you realize that they're using the base terminal of their OS, and you go like, oh my God, you live in an undecorated house. How can you live like that, right? So this is where I want to introduce this thing called Oh My Z Shell, which is sort of a framework extension. I don't know what they call it for the Z Shell sort of command line. So I think if you're a Mac users now, they all use Z Shell by default, so it should be easy to adopt. For others, you may have to switch. If you're interested, you don't have to. Similar for just having nice prompt and nice sort of command line. I think there's something called Starship and a few other projects like this. So Oh My Z Shell will come with a whole bunch of themes that you can just where you can easily adapt how your prompt looks like. I know you're all geeks, so you know that you can edit your prompts, but if you're not a geek, and you can just like click one button or change one name in one config file, and it will just do everything for you. It makes your life much easier, and it will your prompt will then tell you on which branch you are, if you have a clean working tree, and a whole bunch of things that I would never have bother to do if I had not discovered this. The other thing of Oh My Z Shell is plugins. There's like 300 of them for just anything from like Git, Debian, Ubuntu, like whatever. And they come with a whole bunch of things. The main thing that they will do is they come up usually with a whole bunch of aliases for your command line. If you're like me and you cannot touch type and you type like a baboon and you make like a typo every third keystroke, this is fantastic. So I started using that, and just like I actually, it's also a very good way to learn new Git or DataLad or Git command, because you realize there's this whole bunch of things, and you're going to start using commands that you would never use otherwise, because you could not be bothered to type them because they're way too long anyway, and you cannot remember them. And what I've started doing, I think 2 years ago, a year ago, I don't remember when I did that, but I was like, DataLad command are too long. I mean, DataLad, just typing that's just way too long. So I just like, no, I need something shorter. So I started creating a plugin for DataLad, and at the moment it just has a bunch of aliases, but I was like, maybe you have some aliases that you could suggest, or maybe there are some that I've put in there, maybe should not be in there. So I'll send a link to the plugin, so you can like make suggestions. And I don't think there is a plugin for git-annex. So maybe that could be something interesting, because I suspect that git-annex also has commands that could be aliased. So there you go. That was my talk with no slides and a computer.
Thank you. I think we, Matthias, I don't know. You seem to be ready.
So let's hope this works. Can I just move that over? Yes, that's great. So I just want to quickly make you aware of a project. So we've heard the term Gin a few times today. Gin is a fork of Gox that enables Gox to be utilized with git-annex. That's great. It's hosted on gin.gnode.org, but it is very much outdated. So the latest commit here is from 3 years ago. On the live branch, it's 4 years ago. And it's hard to update because it not just adds git-annex, but there are more changes. So I took a look at what's available otherwise. And there's this great Gitty fork, which just adds a patch set that enables git-annex on Gitty, which is like, I checked, it's 2,300 lines of code, so somewhat reasonable, which can easily be adapted to the latest Gitty release to keep up with security fixes and stuff like that when you're self-hosting it. So if you need a self-hosted Git service which can deal with git-annex, this might be it. Yes, so yeah, you can see it's a bit outdated right now, but I've tried it and it does apply with like 3 merge conflicts on the latest version of Gitty as well. I have another fork of it which adds some functionality that we use at our institute, IEK7, Forschungszentrum, for our instance, which you can also publicly find under address.fzjulich.de. If you want to check that out, how that looks, and yeah, if you click on Explore, you can find some repositories here, for example, one from my master thesis. And what's cool about it is if you have data stored in git-annex in such a repository, you can get web previews without an issue. For example, here's a netcdf file. That's something that, yeah, it's a binary file with metadata for like atmospheric variables and stuff like that. And well, you can, with the Gitty functionality to customize these previews, you can script it to, for example, show you a header of that file, what it contains. So in this case, there's a time series in here. Just a quick disclaimer, I'm not a developer of this project. I sort of found it as a user. There's no code in it from me yet. I have some pull requests open to fix some rough edges that I hope can get merged at some point. Yeah.
Awesome, thank you. So we have some 5 minutes left. I think he wanted. Oh, many people want. So we've we can collectively decide to just ignore the schedule. Like oh no, but
I'll be quick. I'll be quick.
1 minute.
Yeah, 1 minute. 1 minute. Will be.
55 seconds.
53. So what I've forgotten to present yesterday as part of any of our talks is actually what's there in that name, DataLad, right? And how it came about. And hopefully it eventually appears. So here we go. No, you want to go to that one. Okay. So what's in that name, right? So DataLad. And let me bring another terminal. Do you know what's in the name Git? So who knows what Git means really in kind of language of humans? So that's pretty much what it is. I'm just kind of setting up the stage, right? So it's a person who deemed despicable, contemptible, so nothing good really, right? Okay, so what's in the name of DataLad? So when it began for us, you've heard that we reserve. Oh no, you haven't heard. Actually, that's what I was doing. This archaeology. We reserved the domain name datagit.org before we even made the first commit in the repository. And in the repository, we had a Git web I've mentioned. Then we had tool page to annex. Code refactored to reside under DataGit Python package in July. And we started to work on proposal in January 2014, right? So that's where suspense begins. We submitted request to softwareconservancy.org on use of Git in the name because they hold the trademark, right? So, and that's my kind of lesson to you, never talk to lawyers. Then in January, we submit proposal with that name, DataGit, and we received response in August from them, must respectfully decline. There is a thread after, but we'll not cover it now. And so we started to work on something which name was kind of flexible, let's put it this way, right? And immediately I flew into Germany, right, so we could resolve that issue once and for all. And entire weekend, we worked really heavily with lots of inspiration from different medium, and which resulted in the best variant of the name, which was FTF.
What?
Exactly. Faster than floppy. If you think about it, it is true, and that acronym is still not reserved. So.
It's easier to type as well.
And exactly. But so with that in my mind, right, I flew back into the States, right, and I think that's where memory becomes murky a little bit because I didn't find yet documental support for that. And Michael messages that he figured it out. Okay, so and he figured it out based on, oh boy, this. So that's the image which inspired the mind of the greatest, right? So if we go back to the terminal, right, and we actually type lad, right, so what lad means is a boy, a man, and it's like only kind of very nice, a companion, a comrade, a mate, right? So it's all good things. So now compared to the previous definition you've seen, right, we are just serving the wide side of the spectrum, you know, when you go from one definition to another one, right? But then there were also negative feedback. We received one about lad culture in 90s in UK. How could you possibly name your project DataLad? It's like the abomination. So, but we didn't rename it since then. So that's the history of the project.
Now you know. Now you know.
Okay.
Okay. How do you feel? Let's go.
Do we still have time?
Sure. 2 minutes.
2 minutes.
Well, for now, it's 2 minutes.
Very, very short and fast. And I just need the. Voila. Yeah. I just want to bring to your attention another very lean distributed data management ecosystem that, anything visible? There it is. Good. There you see the slides, yeah. It's only 2 or 3 slides briefly, called DTool and DServer, and at least 2.5 groups in Freiburg where me as a data student and my coworker Ashwin over there as a developer are based. So it is in many aspects, DTool and DServer are in many aspects very similar to DataLad, but much simpler and smaller and frailer. It packages data and metadata together in data sets and assigns UIDs as persistent identifiers. At its core, it's a Python library with a command line client designed to outlive, so the data sets are meant to outlive the software. Very easily extendable. And one thing that is maybe a bit different is that there is no underlying dependency on Git. It's standardized via its API and can move these data sets also around different storage infrastructure. And then there's another thing that we call the server, which is basically adding the findability when you think in terms of FAIR to those data sets, that launches an ad hoc repository on some random storage infrastructure where a few of those data sets are collected. I won't go into much detail of why I'm using this at LiveMats, because it would take too long. But what we would actually like to propose is, for the hackathon, is making DTool data sets and DataLad data sets interoperable in some manner, or at least think about whether that would be possible. I think you can find a lot of information on this little DTool ecosystem in the hackathon Git repository. We provided a pull request there with information on that. There are a few references. In particular, we have a publication on the server in review. I hope that will go through smoothly. The preprint is findable online. With that, I'd like to thank you and hope that this would be something interesting for the hackathon.
Thank you. So with 14 minutes till the lights go out.
In 40 minutes?
Yes, 14. But not, well, 14 total.
Okay, let me make this quick. I just got some requests to show what this textual framework looks like, and so this is a repository I just made from in Matthias's address Gitty plus annex thing. It works, I can confirm. And if we just randomly open this control center here, it really behaves like a website. So you can scroll. It live resizes everything. So you could also like grab the site and it will reflow the text. This is a terminal, mind you, right? It's not a website, it's a terminal. And you have these tabs here. You have these nice animations. You can have like a syntax highlighting in simple terms. You can have light mode and dark mode. You can take screenshots. You can, yeah, it's quite funny. And this is all Python. This is like 300, 400 lines of Python for all of this, and this makes GUI programming fun again, just as a note. And just as a small note on the special remote, who was it? Z standard compressing instead of. He left. Oh, amazing. I can still show it a bit. I wrote a benchmarker once for compression algorithms, and these are just some results. And my findings is that we should all use XZ.
Perfect timing.
If I mean, he was using like Z standard level 22 in ultra mode, which is, I mean, it's reasonable to think that the more like compression intensity you add, the better it is. But I find with Z standard, like the bigger levels do not really make sense. They just take more time, more RAM, and don't really compress better. Nothing beats XZ actually, like in the ones that I compared. XZ is of course slow, but it's fairly RAM. It doesn't use as much RAM. Sorry for the alpha problems here. Down here you can see XZ. It uses very little RAM compared to the other things.
and Z standard is just like the RAM usage skyrockets in the 22 level. So you use like 900 megabytes of RAM for, what was this, like a 40 megabyte file to compress? Like what the heck is this? Yeah, just as a note.
All right, thank you. Who's still itching?
Can I just have like less than 1 minute?
Sure.
Okay. No, this is, I've thought about it and I think I would regret it if I didn't share this. And so I've been playing around with this tool. And it's called Git Bunch. I was thinking of calling it Git Bind. Is it? Oh my God, is it coming up?
There you are.
Okay. Really quick, it solves a really big issue that I've been having. It might be generally useful. I'm just trying to get my terminal to come up here. It creates an octopus commit, merge and a branch that essentially anchors any other branches that you provide in a ref spec. And what that can be used for is non-destructively cleaning out your branch namespace. And it's got a bunch of other uses. It's, even with git-annex, it lets you programmatically bundle multiple branches together in a way which can be, really easy to extract. So I have a simple proof of concept here. This is a burner laptop. It doesn't have all my stuff installed on it. No, I mean, but I just want to give you an example of with a CRC. Okay, so we got some branches right here. So people git bunch, save. By default, it creates a branch which just is all the locally checked out branches, and it creates, so it uses no actual data is added. It stores all of this in metadata. So it creates in the commit message a key value of every single value. So now we can, and if we check this branch out, right? Contains nothing. So let's, sorry. All right, so we got no other branches. So git bunch redecorate. Oh, I have to give it the name of the branch. But the point is, like before I was playing, there's one called audio branches. Audio branches. What the heck was it? I haven't touched this in a few months, and I dusted it all off. And I really don't think I should be using B as a name for...
I think we should move on.
Okay, all right. What? Okay, anyway, thanks for your time. I just wanted to share that.
Thank you. I think the chat rooms will continue to exist. They're not going away. So if you have the solution, you just post it as a video. So almost unfortunately, this brings us to the end of the meeting time of this first installment of Distribits. I think it was fantastic when we discussed that we could theoretically do something like that. 3/4 of a year ago. This would have been basically the best possible outcome. At least that's how I experienced it. And I think you've seen that there's so much energy in the room. We could just continue, throwing bits and pieces that are interested at each other, and we would enjoy that very much. Unfortunately, all things need to come to an end, and at least the conference part of the meeting is over. And fortunately for some of you, we'll meet again tomorrow at 9, again in this building, but this time the 3rd floor, and then we can explore a few of these ideas even further. But of course, I mean, the optimal outcome would be if that all these possible collaborations that we've heard about, or you could somehow already, you know, grasp in the air, that they actually flourish over the time, and ideally they turn into a richer, more connected ecosystem, not only of the tools, but also of the people. And this is really what this meeting has been about. I mean, we all went through a period of, you know, not seeing people that much than before. And so this was a very nice event, like for me personally, but also I think for everybody else. I want to take the time to acknowledge how this was possible to do it, and first of all, I hope you got the idea that that wasn't, you know, one person that organized all this, but it was actually a group of people that kind of, you know, almost very, you know, how do you say that? Yeah, well, I wanted to end with that, so I will just continue with this. So even the organization of the meeting was very distributed, and I think at no point there was one person that knew all of what would happen and what would be required to do in order to have that meeting. So you know, I think I'm totally glad that we have this group of people that works together so nicely, and so I'll just go over a few names alphabetically. So this is we have to thank Adina and Alex and Christian and Isaac and Joey and Laura and Michael and Stefan and Ute and Jarek for making this possible. And I want to, you know, have a round of applause. And then I'm also very happy that we could run this meeting the way we did it. So without, you know, the usual overhead of commercialization that you have in conferences, right? So this meeting venue was provided to us by Heinrich Heine University, and I think that's an absolute treasure to have, right? And I think everything was nicely, the acoustics is nice, the air is nice, it's nicely located. We could go out and have lunch, and I think that was great. So Heinrich Heine University, I think that's excellent. And then, of course, there are still some things that you know have to be acknowledged in the real world, and some things cost money. So I also want to thank Simon Eickhoff, who is the head of the INM7 Institute at the Research Center in Jülich, and also the director of the Institute for Systems Neuroscience here at Heinrich Heine University, for being the administrative umbrella that allowed us to have this kind of flexibility. And I think that made many things possible. And then, thank you, 2 minutes. And then we started like this, and I think it has proven to be true. It is you who deserve also a big thanks, because what you can never foresee is, of course, what would the interactions turn out to be like. And every single panel discussion was an interesting one. All the time exhausted with interesting questions, and I hope there were even more questions in the evenings that followed the talk. So I think that it just was really great, and I want to thank you all for coming, and thank you all for bringing your entire attention and your positive attitude and energy to the room. And I think for me personally, it was a great motivator to continue into the future. Thank you. And then I want to spend the last minute speculating about the future, because we started to talk about, and it was so nice that it would be a shame to not do it again in some fashion at some point and somewhere. And I don't think there is a concrete idea how it would work. But I think we should stay in touch and discuss that, and ideally not just a few, but with you that you have experienced that, we would be interested in your opinion. So we should continue to use the Matrix chat room to form ideas of how this could evolve. So I'm looking forward to that. And the last statement I want to make is I want to thank the people in the back that took care of streaming all this to the world. And for all we've heard, this has worked excellent and has enabled people to participate and to know what we have been talking about that didn't have the chance to come here. And we'll turn this information also, chunk it up nicely into individual talks so that you can also point people to this wealth of information that we've collected over the past 2 days. Thank you. And with that, I hope you have a nice evening, and looking forward to see some of you tomorrow and everybody else at some point in the near future. Thank you.